Hello there and welcome. Tonight I want to take you somewhere special, somewhere beyond the familiar boundaries of our world, out into the vast cathedral of space where mysteries drift silently through the darkness. Settle in, make yourself comfortable, and let your mind wander with me as we explore one of the most intriguing questions that has emerged from our observations of the cosmos in recent years. It's a question that might seem far-fetched at first, perhaps even impossible, but as we journey together through the evidence and possibilities, you might find yourself wondering if we've stumbled upon something profound, something that could fundamentally alter our understanding of reality itself. What if an interstellar visitor, a cosmic wanderer from beyond our solar system, carried within it something we cannot yet perceive or measure, something that could gently, quietly influence the very fabric of space-time around us? Not in any dramatic or catastrophic way, but in a subtle, almost imperceptible manner that might take centuries or millennia to fully manifest. This is the story of 3I Atlas, an object that passed through our solar system not long ago, and the fascinating possibility that it might have brought with it seeds of change we're only beginning to contemplate. You see, we live in an age where humanity has developed instruments sensitive enough to detect visitors from other star systems, objects that have travelled for millions of years through the cold emptiness between stars before briefly passing through our cosmic neighbourhood. 3I Atlas was one such visitor, discovered by astronomers who noticed its peculiar trajectory, a path that clearly indicated it had come from somewhere far beyond the gravitational influence of our Sun. As we speak, it continues its journey into the darkness, having already passed beyond our ability to observe it directly, but the questions it raised during its brief appearance continue to resonate through the scientific community. Consider for a moment the sheer improbability of our detection of this object. Space is vast, incomprehensibly vast, and the chances of an interstellar object passing close enough to Earth for us to notice it are astronomically small. Yet here we are, having witnessed not just one but several such visitors in recent years. Perhaps this tells us something important about the nature of interstellar space, that it might be filled with far more wandering objects than we ever imagined, each one carrying information about distant star systems, other worlds, and possibly even phenomena we haven't yet discovered. The name 3I Atlas itself tells a story. The 3I designation marks it as the third confirmed interstellar object we've detected, following Oumuamua and 2I Borisov. Atlas refers to the Asteroid Terrestrial Impact Last Alert System that first spotted it, a network of telescopes designed to protect Earth by identifying potentially hazardous objects. But what if the real significance of 3I Atlas isn't about physical impact at all? What if its importance lies in something far more subtle, something that doesn't collide with planets, but instead interacts with the fundamental forces that govern reality? As you drift deeper into relaxation, imagine yourself floating in space, watching this ancient traveller glide silently past. It moves with a purpose that seems almost deliberate, following a trajectory determined by gravitational forces acting over cosmic timescales. The object itself appears unremarkable at first glance, perhaps a chunk of ice and rock worn smooth by eons of cosmic radiation. But appearances can be deceiving, especially when we're dealing with objects that have journeyed through regions of space we can barely imagine. Scientists studying 3I Atlas notice several peculiarities that set it apart from typical comets or asteroids. Its composition seemed unusual, reflecting light in ways that didn't quite match our models of what interstellar objects should look like. Some researchers suggested it might contain exotic ices, compounds formed under conditions that don't exist in our solar system. Others wondered if its internal structure might be fundamentally different from anything we've encountered before, perhaps organized in ways that could only occur in the extreme environments around other stars. But what really captures the imagination is the possibility that 3I Atlas might carry something we cannot directly observe, something that exists at the boundaries of our current understanding of physics. You see, We know that the universe is filled with phenomena we can't directly perceive. Dark matter, for instance, makes up most of the mass in the universe, yet we can only detect it through its gravitational effects. Dark energy drives the accelerating expansion of space itself, yet its nature remains one of the deepest mysteries in cosmology. What if interstellar objects like 3I Atlas serve as carriers for similarly exotic phenomena? Imagine, if you will, that certain regions of space contain fields or particles that we haven't yet discovered, phenomena that arise from the unique conditions around other stars or in the vast spaces between them. These might be incredibly subtle, interacting with ordinary matter only in the weakest possible ways, making them nearly impossible to detect with our current technology. But over time, over vast scales of space and time, even the smallest influences can accumulate into significant effects. The concept isn't as far-fetched as it might initially seem. We already know that space isn't empty, but filled with a complex tapestry of fields and forces. Electromagnetic fields permeate the cosmos, carrying light and radio waves across billions of light years. Gravitational waves ripple through space-time itself, generated by the most violent events in the universe. Quantum fields give rise to virtual particles that pop into and out of existence in the vacuum of space. Perhaps there are other fields, other forces that we simply haven't discovered yet because they interact so weakly with the matter and energy we're familiar with. Now, you might wonder, what could the word collapse mean in this context? We're not talking about anything dramatic or catastrophic, nothing that would threaten Earth or humanity in any immediate sense. Instead, think of collapse as a gradual transition, a slow shift from one stable state to another, like water slowly freezing into ice, or a magnetic field gradually reversing its polarity. In physics, collapse often refers to a change in the fundamental state of a system, a transition that might take place over timescales far longer than human civilization has existed. Consider the concept of vacuum decay, a theoretical possibility in quantum field theory, where the vacuum of space itself might not be in its most stable possible state. If this were true, and if something could trigger a transition to a more stable state, it would propagate through space at the speed of light, fundamentally altering the laws of physics within the affected region. But don't let this alarm you. Even if such a thing were possible, the universe has existed for nearly 14 billion years without such an event occurring in our vicinity, suggesting that if such transitions are possible, they're extraordinarily rare. What's more intriguing is the possibility of much subtler forms of collapse or transition. Perhaps certain exotic fields could influence the rate of quantum processes, slightly altering the probability of certain events occurring. Over time, these tiny changes could accumulate, leading to macroscopic effects we might eventually notice. Or perhaps interaction with exotic matter could influence the local structure of space-time itself, creating regions where the fundamental constants of nature are slightly different from what we're used to. 3I Atlas spent only a brief time in our solar system, following a hyperbolic trajectory that brought it in from interstellar space and sent it back out again, never to return. During its passage, it was subjected to the sun's heat and radiation, causing some of its surface materials to sublimate into space. Astronomers studied the spectrum of light reflected from its surface and the composition of the gases it released, looking for clues about its origin and nature. What they found was both familiar and strange, a mixture of expected compounds and unusual signatures that didn't quite fit our models. Some researchers have suggested that 3I Atlas might have formed in a region of space very different from our own solar system, perhaps around a star with a different composition, or in a nebula with unusual chemical properties. Others have wondered if it might have been altered during its long journey through interstellar space, transformed by exposure to cosmic rays, magnetic fields, and other phenomena we don't fully understand. Each possibility opens up new questions about the nature of matter and energy in the cosmos. As we contemplate these possibilities, it's worth remembering that we're still in the very early stages of our exploration of interstellar visitors. We've only recently developed the technology to detect and track such objects, and our sample size remains frustratingly small. Each new discovery teaches us something, but also reveals how much we don't know. Perhaps in the coming decades, as our detection capabilities improve and we observe more interstellar objects, patterns will emerge that help us understand what Three-Eye Atlas really was, and what, if anything, it might have brought with it. The idea that cosmic visitors could carry seeds of change isn't entirely without precedent in scientific thinking. We know that meteorites have delivered organic compounds to Earth, possibly playing a role in the origin of life. We know that cosmic rays can influence cloud formation and climate patterns. We know that the solar system passes through regions of varying interstellar medium density as it orbits the galaxy, and these passages might have influenced Earth's climate and the evolution of life. If relatively mundane phenomena can have such significant effects, what might more exotic influences be capable of? Picture yourself now as a cosmic observer, watching not just Three-Eye Atlas but the countless other objects that must be drifting through interstellar space. Each one is a messenger from another place and time, carrying information about conditions in distant regions of the galaxy. Most pass by unnoticed, too small or too distant for us to detect, but occasionally one comes close enough for us to observe, offering us a glimpse of the wider universe beyond our solar system. The trajectory of Three-Eye Atlas tells us it came from the general direction of the constellation Lyra, though its exact point of origin remains unknown. It might have been travelling for millions or even billions of years before reaching us, ejected from its home system by gravitational interactions with planets or companion stars. During its long journey, it would have been exposed to the full range of interstellar phenomena: cosmic rays, magnetic fields, dust, gas, and perhaps things we haven't yet discovered. What transformations might an object undergo during such a journey? We know that cosmic rays can create exotic isotopes and alter the crystalline structure of minerals. We know that long exposure to the vacuum of space can cause volatile compounds to sublimate away, leaving behind a concentration of more stable materials. But what about more subtle changes? Could interaction with dark matter particles leave some kind of signature? Could passage through regions of unusual space-time curvature alter an object's quantum properties? These questions might seem abstract, but they touch on fundamental issues in physics and cosmology. We're still trying to understand the nature of dark matter and dark energy, which together make up about 95% of the universe. We're still exploring the implications of quantum mechanics and general relativity, two theories that work brilliantly in their respective domains but resist unification. We're still discovering new phenomena, from gravitational waves to time crystals to quantum entanglement over cosmic distances. In such a universe, full of mysteries and unknowns, is it really so strange to wonder if an interstellar visitor might carry something unexpected? As you continue to relax, letting these ideas wash over you like gentle waves, consider the possibility that Three-Eye Atlas represents not a threat but an opportunity. Each interstellar object that passes through our solar system is a natural experiment, a test of our theories and assumptions about the cosmos. By studying these visitors, we can learn about conditions in other star systems, the processes that shape planetary formation, and perhaps even discover new physics. The scientific community has proposed various missions to study future interstellar objects, including spacecraft that could rendezvous with them as they pass through the solar system. Imagine what we might learn from direct sampling of material that formed around another star, material that has been isolated from our solar system for billions of years. Such samples could revolutionize our understanding of planetary science, chemistry, and perhaps even biology if we were to discover organic compounds or other biosignatures. But for now, Three Atlas has passed beyond our reach, continuing its eternal journey through the cosmos. It carries with it whatever secrets it holds, whether they're mundane or extraordinary. Perhaps it's nothing more than a chunk of ice and rock, interesting only for its interstellar origin. Or perhaps it carries within it something more subtle, something that interacted with our solar system in ways we haven't yet detected or understood. The notion of seeds of collapse, as we're exploring it tonight, isn't about destruction or catastrophe. Instead, it's about the possibility of gradual change, of transitions that occur over timescales far longer than human experience. Just as a seed planted in soil might take years to grow into a tree, any influence 3 Atlas might have had could take centuries or millennia to manifest. And like a seed, the changes might be beneficial rather than harmful, leading to new states of existence we can barely imagine. In quantum mechanics, we're familiar with the idea that observation can cause a wave function to collapse, transitioning from a superposition of states to a single definite state. This collapse is instantaneous and fundamental to the nature of reality as we understand it. But what if there are other forms of collapse, other transitions that occur more gradually? What if certain triggers could cause slow changes in the vacuum state of space, in the strength of fundamental forces, or in the behavior of quantum fields? These possibilities might sound like science fiction, but they're grounded in serious theoretical physics. The concept of false vacuum decay, for instance, has been studied extensively by cosmologists trying to understand the early universe and its possible futures. The idea that fundamental constants might vary across space and time has been proposed to explain certain astronomical observations. The possibility that our universe might be just one of many, each with different physical laws, is taken seriously by many physicists. As we move deeper into our exploration, let's consider what we actually observed about 3I Atlas during its passage. Astronomers tracked its motion carefully, measuring its position and velocity with remarkable precision. They analyzed the spectrum of sunlight reflected from its surface, looking for clues about its composition. They monitored it for signs of outgassing, the release of volatile compounds that creates the beautiful tails we see on comets. Every piece of data was precious, given how briefly the object was observable. One of the most intriguing aspects of 3I Atlas was its apparent fragmentation. As it approached the Sun, astronomers noticed that it seemed to be breaking apart, possibly due to thermal stress or the sublimation of volatile ices that held it together. This fragmentation provided an unexpected opportunity to study its interior composition, as fresh surfaces were exposed to sunlight for the first time in perhaps billions of years. The spectrum of light from these newly exposed surfaces showed subtle differences from the original surface, suggesting a complex internal structure. Some researchers have speculated that this fragmentation might have released more than just ordinary gases and dust. If 3I Atlas contained exotic materials or carried unusual fields, their release into the solar system could have created a kind of natural experiment. Of course, detecting such subtle influences against the background of normal solar system phenomena would be extraordinarily difficult, perhaps impossible with our current technology. But the possibility remains intriguing. The timing of 3I Atlas's discovery and passage is also worth contemplating. We detected it in 2019, just as humanity was entering a period of rapid technological advancement in astronomy and space science. New telescopes and detection systems are coming online that will dramatically increase our ability to find and study interstellar objects. The Vera Rubin Observatory, for instance, will survey the entire visible sky every few nights, potentially discovering many more interstellar visitors. The James Webb Space Telescope can analyze the composition of such objects in unprecedented detail. Perhaps we're on the verge of discovering that interstellar objects are far more common than we thought, that our solar system is regularly visited by cosmic wanderers from other star systems. If so, the question of what they might carry becomes even more significant. Could some of them harbour exotic matter created in the extreme environments around neutron stars or black holes? Might others carry organic compounds or even microscopic life forms capable of surviving the journey between stars? Could some interact with dark matter or dark energy in ways that leave detectable signatures? As you drift along with these thoughts, feeling yourself becoming more relaxed with each passing moment, Consider how our perspective on the universe has changed over time. Just a few centuries ago, we believed Earth was the center of everything, with the sun, moon, and stars revolving around us. Then we discovered we're on one planet orbiting one star among billions in our galaxy. Then we learned our galaxy is one among billions in the observable universe. Each expansion of our perspective has made us seem smaller, yet somehow more connected to the cosmic whole. The discovery of interstellar objects like 3I Atlas represents another expansion of our perspective. We're not isolated in our solar system, but part of a galactic community where objects regularly travel between stars. These cosmic messengers connect us to distant regions of space and time, carrying information about places we may never directly explore. In a sense, they make the galaxy feel smaller, more interconnected, more like a vast ecosystem where materials and perhaps information flow between stellar systems. The word collapse in our title tonight carries multiple meanings, each worth exploring as we continue our journey. In the most literal sense, 3I Atlas itself experienced a form of collapse as it fragmented during its solar passage. But we're also considering more abstract forms of collapse, the collapse of our assumptions about the isolation of stellar systems, the possible collapse of quantum states or field configurations, and perhaps even the collapse of our current understanding of physics as we discover new phenomena. There's something deeply peaceful about contemplating these vast scales of space and time, these subtle possibilities that play out over millions of years. Our daily concerns and anxieties seem to fade when we consider processes that unfold over geological or cosmic timescales. The universe continues its slow evolution, indifferent to our immediate worries, yet somehow including us in its grand unfolding. We're made of star stuff, as Carl Sagan famously said, and perhaps we're influenced by interstellar stuff in ways we're only beginning to understand. Let's take a moment to appreciate the sheer improbability of our situation. Here we are, conscious beings on a small planet, capable of detecting and studying objects that come from other star systems. We've developed mathematics and physics sophisticated enough to model the behavior of matter and energy across the cosmos. We've built instruments sensitive enough to detect gravitational waves from colliding black holes billions of light years away. And now we're beginning to study actual samples of material from beyond our solar system, even if only through remote observation. 3I Atlas, during its brief appearance, was observed by telescopes around the world and in space. Amateur astronomers contributed observations alongside professionals, all working together to extract every bit of information possible from this fleeting visitor. The data collected will be analysed for years to come, as scientists develop new techniques and theories to interpret what we saw. Perhaps hidden in that data are clues to mysteries we haven't even formulated yet. The collaborative nature of this research is worth noting. When an interstellar object is discovered, alerts go out to observatories worldwide. Telescopes are redirected, observations are coordinated, and data is shared freely among researchers. It's a beautiful example of humanity working together to understand something larger than ourselves. In a way, the study of objects like 3I Atlas brings out the best in us, our curiosity, cooperation, and desire to understand our place in the universe. As we continue to relax and explore these ideas, let's consider what seeds might mean in our context. Seeds are packages of potential, containing within them the information and materials needed to create something new. They can remain dormant for extended periods, waiting for the right conditions to germinate. Once activated, they can transform their environment, turning bare soil into a garden or a forest. The seeds we're contemplating tonight might be similar, packages of potential that could gradually transform our understanding of reality. What kinds of seeds might an interstellar object carry? At the most basic level, it could carry chemical seeds, molecules, or compounds that don't naturally occur in our solar system. These might include exotic ices, unusual isotope ratios, or organic compounds formed under alien conditions. More speculatively, it might carry information seeds, patterns or structures that could influence the organization of matter and energy around them. Or it might carry field seeds, disturbances in quantum fields or space-time itself that propagate outward from the object. The idea of information as a fundamental aspect of reality has gained traction in physics in recent years. Some theorists suggest that information, not matter or energy, might be the most basic component of the universe. In this view, particles and forces are emergent properties of underlying information structures. If this is true, then an object like 3I Atlas might carry information patterns that could influence the behavior of matter and energy in subtle ways. Consider how a small change in initial conditions can lead to dramatically different outcomes in complex systems. This is the essence of chaos theory, often illustrated by the butterfly effect. A butterfly flapping its wings in Brazil might ultimately cause a tornado in Texas. In the context of our solar system, could the gravitational influence of 3I Atlas, tiny as it was, have altered the trajectories of asteroids or comets in ways that will only become apparent centuries from now? Could its passage have introduced subtle perturbations that will accumulate over time? But we're thinking beyond mere gravitational effects tonight. What if 3I Atlas influenced quantum processes in ways we can't yet detect? Quantum mechanics tells us that reality at the smallest scales is probabilistic rather than deterministic. The outcomes of quantum events are governed by probability distributions, and these probabilities can be influenced by external fields and forces. If 3I Atlas carried exotic fields or particles, it might have slightly altered these probability distributions throughout the solar system. Such effects would be incredibly subtle, perhaps impossible to detect directly. But over time, over countless quantum events, even tiny changes in probabilities could lead to macroscopic effects. It's like a cosmic version of loaded dice, where the bias is so small that you'd need to roll them millions of times to notice. But given enough time, the effect becomes undeniable. The universe has plenty of time, and quantum events happen continuously at every point in space. As you sink deeper into relaxation, letting your mind wander through these possibilities, remember that we're not discussing anything alarming or threatening. If such influences exist, they've been part of the cosmic environment for billions of years. Earth has been bombarded by interstellar particles and radiation throughout its history, yet life has not only survived but thrived. Perhaps these influences, rather than being harmful, are part of the creative process that drives the evolution of matter, energy, and possibly life itself. The passage of 3 Atlas through our solar system was brief on cosmic scales, lasting only a few months from discovery to departure. But imagine the journey that led to that moment. This object might have formed billions of years ago in the disk of dust and gas around a young star. It might have orbited that star for millions of years before being ejected by a close encounter with a planet or another star. Then began its long voyage through interstellar space, a journey that might have lasted longer than our solar system has existed. During that journey, 3I Atlas would have been essentially alone, drifting through the vast emptiness between stars. The temperature would have been close to absolute zero, with only the faint glow of distant stars and the cosmic microwave background for company. Any volatile compounds on its surface would have long since sublimated away, leaving only the most stable materials. It would have been bombarded by cosmic rays, gradually accumulating damage and creating exotic isotopes in its interior. Then, after eons of solitude, it encountered our sun's gravity, drawing it into the solar system for a brief visit. The sun's warmth awakened dormant processes, causing ices to sublimate and the object to fragment. For a few months, it was bathed in sunlight more intense than it had experienced in billions of years. Then, following the inexorable laws of orbital mechanics, it swung around the sun and headed back into the darkness, never to return. There's something poignant about this story, isn't there? An ancient traveller, older than our world, passing briefly through our neighbourhood before continuing its eternal journey. We caught a glimpse of it, studied it as best we could with our limited time and tools, and now it's gone. But the questions it raised remain, rippling through the scientific community like waves on a cosmic pond. What if every interstellar object that passes through our solar system leaves some kind of trace, some subtle influence that accumulates over time? Our solar system has existed for about 4.5 billion years, and during that time, it must have been visited by countless interstellar objects. Most were too small or passed too far away for us to have noticed them even if we'd been watching, but they were there, each one potentially carrying something unique from its place of origin. Imagine the solar system as a kind of cosmic collector, gathering influences from across the galaxy over billions of years. Each interstellar visitor adds something to the mix, whether it's just ordinary matter or something more exotic. Over geological timescales, these influences might accumulate, creating a unique environment that has shaped the evolution of our planets and possibly life itself. We are, in a very real sense, products not just of our solar system, but of the wider galaxy. The concept of panspermia, the idea that life might spread between star systems via meteoroids, asteroids, or comets, has been discussed by scientists for over a century. While we have no direct evidence for it, we know that some organisms on Earth can survive the extreme conditions of space. If life can spread between stars, might other things spread as well? Could there be a kind of cosmic ecology, where different star systems exchange not just matter, but information, patterns, or even physical laws? As we contemplate these possibilities, it's important to maintain a balance between speculation and skepticism. Science progresses by considering new ideas while demanding evidence to support them. The suggestions we're exploring tonight about 3i Atlas and seeds of collapse are speculative, based on possibilities allowed by our current understanding of physics, but not yet supported by direct evidence. This is how science often works at its frontiers, exploring what might be possible while waiting for technology and observations to catch up. The fragmentation of 3i Atlas as it approached the Sun provided an unexpected opportunity to study its internal structure. When a comet or asteroid breaks apart, it reveals materials that have been shielded from space weathering, potentially preserving information about conditions when and where the object formed. The spectroscopic analysis of the fragments showed a complex mixture of compounds, some expected and others surprising. One particularly intriguing observation was the detection of certain emission lines that didn't quite match known compounds. While this could simply be due to unusual temperature or pressure conditions, some researchers have suggested it might indicate the presence of materials not commonly found in our solar system. These could be exotic ices formed under different stellar conditions, or perhaps organic compounds created through processes we haven't observed before. The rate at which 3i Atlas fragmented was also unusual, happening more rapidly than models predicted. This could suggest an internal structure different from typical solar system comets, perhaps with planes of weakness created by repeated thermal cycling during its interstellar journey. Or it might indicate that the object was held together by different forces than we're used to, forces that failed under solar heating in unexpected ways. Each anomaly, each unexpected observation adds to the mystery. Science is often portrayed as a process of finding answers, but just as often, it's about discovering new questions. 3i Atlas has given us plenty of both. We've learned that interstellar objects can be detected and studied with our current technology, but we've also realized how much we don't know about these cosmic wanderers. As you continue to drift towards sleep, carried along by these cosmic contemplations, consider how the story of 3i Atlas connects to larger themes in science and philosophy. The idea that small causes can have large effects, that invisible influences shape our reality, that we're connected to the wider universe in ways we're only beginning to understand. These are profound concepts that have occupied human thought for millennia. Ancient philosophers wondered about the nature of change and permanence, about what causes transformations in the world around us. They developed concepts like the four elements, the music of the spheres, and the harmony of the cosmos. While our modern scientific understanding is far more detailed and accurate, we're still grappling with similar questions. What causes change? How do different parts of the universe influence each other? Are there hidden connections we haven't discovered? The possibility that 3i Atlas carried seeds of collapse, in whatever form we imagine them, touches on these deep questions. It suggests that change might come not from within, but from without, carried by messengers from distant places and times. It implies that our solar system, and Earth itself, are not closed systems but open to influences from the wider galaxy. It reminds us that we're part of a larger story, one that began long before Earth formed and will continue long after we're gone. Think about the chain of events that led to our detection of 3i Atlas. Stars had to form and die, creating the heavy elements necessary for rocky planets. Our solar system had to form in just the right way to produce a planet capable of supporting life. Life had to evolve for billions of years, eventually producing beings capable of building telescopes and understanding orbital mechanics. Civilization had to develop to the point where we could construct instruments sensitive enough to detect faint objects moving through space, and 3 Atlas had to pass close enough at just the right time for us to notice it. When you consider all these contingencies, our brief encounter with 3i Atlas seems almost miraculous. Yet it happened, and it will happen again with other interstellar visitors. Each encounter is an opportunity to learn, to test our theories, and to expand our understanding of the cosmos. Perhaps one day we'll discover that these visitors do indeed carry seeds of change, influences that have been shaping our solar system in ways we never suspected. The notion of collapse we're exploring tonight doesn't necessarily mean destruction or ending. In many contexts, collapse is a transition to a more stable or organized state. When a wave function collapses in quantum mechanics, it transitions from uncertainty to certainty. When a gas cloud collapses to form a star, it transforms from diffuse chaos to organized fusion. Perhaps the seeds carried by 3i Atlas, if they exist, are seeds of transformation rather than destruction. Catalysts for changes that could lead to new forms of order or complexity. We live in a universe that seems fine-tuned for complexity and life. The fundamental constants of nature, the strength of gravity, the mass of electrons, the speed of light, all have values that allow atoms to form, stars to shine, and chemistry to produce the vast array of compounds we see around us. If any of these constants were slightly different, the universe might be sterile and lifeless. This fine-tuning has led some scientists to propose that there might be many universes, each with different constants, and we naturally find ourselves in one that permits our existence. But what if the constants aren't truly constant? What if they can change slowly over cosmic time? Some theories suggest that what we call constants might actually be fields that can vary across space and time. If this is true, then interactions with exotic matter or fields carried by objects like 3i Atlas could potentially influence these constants in local regions of space. The changes would be incredibly subtle, perhaps undetectable with current technology, but they could accumulate over billions of years. This brings us to one of the most profound questions in cosmology. Is our universe stable? We know that it has existed for nearly 14 billion years, which suggests a high degree of stability. But stability doesn't necessarily mean permanence. Many systems can remain stable for long periods before transitioning to new states. The question is whether our universe is in its most stable possible configuration, or whether it's in a metastable state that could eventually transition to something else. The concept of false vacuum decay, which we touched on earlier, is one scenario where the universe might not be in its most stable state. If the Higgs field, which gives particles their mass, is not at its minimum energy level, it could potentially transition to a lower level. This transition would fundamentally alter the nature of matter and forces, effectively creating a new universe with different physical laws. While this might sound alarming, calculations suggest that even if our vacuum is metastable, it would likely remain stable for trillions of years. but perhaps there are other, more subtle forms of transition possible. Perhaps certain regions of space could develop slightly different properties while remaining compatible with neighbouring regions. Perhaps the boundaries between different phases of matter or space-time could shift gradually, like the slow advance and retreat of glaciers during ice ages. These changes might be so slow and subtle that they're imperceptible on human timescales, but significant over cosmic time. 3I Atlas has left our solar system now, continuing its journey through interstellar space. Where will it go next? Its trajectory will be influenced by the gravitational fields of stars it passes near, gradually changing course over millions of years. Eventually it might encounter another star system, perhaps one with planets, and possibly even life. If it carries seeds of any kind, it might plant them there, continuing a cosmic process of exchange and transformation that has been going on since the galaxy formed. Or perhaps 3I Atlas will never encounter another star system closely. Space is vast and stars are far apart. It might wander the galaxy for billions of years, slowly eroding from cosmic ray bombardment, gradually losing mass to sublimation even in the cold of interstellar space. Eventually it might be nothing more than a cloud of dust, dispersed so thinly that its atoms become part of the interstellar medium, ready to be incorporated into new stars and planets billions of years from now. There's something beautiful about this cosmic recycling, isn't there? Matter and energy constantly flowing, transforming, reorganizing into new patterns and structures. The atoms in your body were forged in the hearts of stars that died billions of years ago. They've been part of interstellar clouds, asteroids, perhaps even other living beings on Earth. Now they're part of you, temporarily organized into the pattern that is your consciousness, before eventually returning to the cosmic flow. In this context, the idea of seeds of collapse takes on a different meaning. Perhaps it's not about collapse at all, but about transformation, about the universe's endless creativity in reorganizing matter and energy into new forms. 3I Atlas might represent just one small part of this vast process, a messenger in an ongoing conversation between star systems that has been happening since the galaxy was young. As we prepare to transition into exploring the architecture of everything, the fundamental structures that hold our universe together, let's carry with us this sense of cosmic connection. 3 Atlas has shown us that our solar system is not isolated, but part of a galactic community where matter, energy, and perhaps information flow between stars. We've considered the possibility that interstellar visitors might carry influences we don't yet understand, seeds of change that could affect the very fabric of reality around us. The universe is full of mysteries, and each answer we find seems to generate new questions. This is not a flaw in our understanding, but a feature of the cosmos itself, which appears to be inexhaustibly complex and creative. As you drift deeper into relaxation, approaching the edge of sleep, remember that you're part of this cosmic story. The atoms in your body have travelled across the galaxy, and who knows what influences they've encountered along the way. Now, as we've established this foundation of cosmic wanderers and the possibilities they represent, let's turn our attention to something even more fundamental. What exactly holds everything together? What are the invisible architectures that maintain the stability of atoms, stars, galaxies, and the universe itself? As we transition into contemplating the architecture of everything, we begin to see how the passage of an object like 3I Atlas through these invisible structures might create ripples we're only beginning to imagine. Consider the delicate balance that holds our universe together, a balance so precise that even the smallest deviation could unravel everything we know. From the smallest quantum fluctuations that govern subatomic particles to the vast cosmic web that connects galaxies across billions of light years, everything is interconnected in ways that challenge our deepest understanding. Tonight, as you settle deeper into comfort, we're going to explore these hidden architectures, these invisible frameworks that maintain the reality we experience every day. Perhaps stability itself is more fragile than we imagine. held by invisible threads that stretch across dimensions we can barely perceive. Think about this for a moment. Everything you see, everything you touch, everything you are is held together by forces that operate according to rules we've only recently begun to understand. The chair you're resting in, the air you're breathing, the thoughts flowing through your mind. All of these exist because of a delicate interplay of fundamental forces that must maintain precise relationships with each other. At the quantum level, particles exist in states of superposition, being in multiple places at once until observed. This isn't just a quirk of mathematics, but a fundamental aspect of reality. The architecture of the quantum world is built on probability clouds and wave functions, on uncertainty principles and quantum entanglement. It's a realm where particles can tunnel through barriers they shouldn't be able to cross, where information can be transmitted instantaneously across vast distances through entangled pairs, where the act of observation itself shapes reality. Now imagine zooming out from this quantum realm to the scale of atoms. Here, electrons orbit nuclei in discrete energy levels, jumping between states by absorbing or emitting photons. The stability of atoms depends on a precise balance between the electromagnetic force that attracts electrons to protons and the quantum mechanical principles that prevent electrons from spiraling into the nucleus. This balance is so exact that a small change in the fundamental constants would make atoms impossible, and without atoms, there would be no chemistry, no molecules, no life as we know it. The architecture continues to build in complexity as we move to larger scales. Atoms bond together through the sharing or transfer of electrons, creating molecules. These molecular bonds have specific angles and distances determined by the quantum mechanical properties of electron orbitals. Water molecules, for instance, have a bent shape with a specific angle between the hydrogen atoms, and this simple geometry gives water its remarkable properties, its ability to dissolve substances, its expansion when freezing, its high heat capacity. Change that angle even slightly, and water would behave completely differently, making life as we know it impossible. Moving up in scale again, we encounter the forces that hold matter together in bulk. The van der Waals forces, weak attractions between molecules, allow geckos to climb walls and water to form droplets. The strong nuclear force binds protons and neutrons in atomic nuclei, overcoming the electromagnetic repulsion between positively charged protons. This force is incredibly strong but operates only over tiny distances, falling off rapidly beyond the size of a nucleus. The precise range and strength of this force determine which elements can exist and which isotopes are stable. But what maintains the architecture of these forces themselves? Why does the electromagnetic force have the strength it does? Why does gravity, the weakest of all forces, nevertheless dominate at cosmic scales? These questions touch on some of the deepest mysteries in physics. Some theories suggest that the forces we observe are actually different aspects of a single unified force that separated in the early universe. Others propose that the strength of forces might vary across space or time, or that they might be influenced by fields we haven't yet discovered. The cosmic web itself is perhaps the grandest architecture we can observe. Galaxies aren't randomly distributed through space, but form a vast network of filaments and voids, like a three-dimensional spiderweb stretching across the observable universe. This structure emerged from tiny quantum fluctuations in the early universe, amplified by gravity over billions of years. Dark matter, invisible and mysterious, provides the scaffolding for this cosmic web, its gravity pulling ordinary matter into the patterns we observe. Within this cosmic architecture, our solar system occupies a relatively quiet neighborhood, orbiting peacefully around the center of the Milky Way galaxy. But even this apparent stability is an illusion of our limited timescale. The solar system oscillates up and down through the galactic disk, periodically passing through regions of higher density where encounters with other stars or interstellar clouds are more likely. These passages might influence the orbits of comets in the outer solar system, potentially sending some toward the inner planets. What if the architecture of reality has weak points, places where it's more susceptible to change or influence? In engineering, we know that structures often fail at joints or connections. Where different materials meet or where forces concentrate, might the universe have similar vulnerabilities? Perhaps the boundaries between different quantum states, the transitions between different phases of matter, or the interfaces between different fields represent points where small influences could have larger effects. Consider phase transitions, those remarkable transformations where matter suddenly changes its organizational structure. Water freezing into ice, iron becoming magnetic below a certain temperature, the sudden emergence of superconductivity in certain materials. These are all examples of phase transitions where the architecture of matter reorganizes itself. Near the critical point of a phase transition, systems become extraordinarily sensitive to small perturbations. A tiny change in temperature or pressure can determine whether water remains liquid or suddenly crystallizes into ice. The universe itself has undergone several phase transitions since the Big Bang. In the first fraction of a second, the fundamental forces separated from each other as the universe cooled. Later, protons and neutrons formed from quarks, then atoms formed from protons and electrons. Each transition represented a fundamental reorganization of the architecture of reality. Some cosmologists speculate that we might be approaching another phase transition, one that could alter the nature of dark energy or the behavior of quantum fields. This is where the passage of an object like 3I Atlas becomes particularly intriguing. If it carried exotic matter or fields, its interaction with our solar system might have been like introducing a seed crystal into a supersaturated solution. Even if the effect was tiny, it might have initiated changes that will propagate over time, gradually altering the local architecture of space-time or quantum fields. These changes might be so subtle that they're undetectable with current technology, manifesting only over geological or cosmic timescales. The concept of symmetry is central to understanding the architecture of physics. The laws of nature exhibit various symmetries. They work the same way in different locations, at different times, in different orientations. These symmetries, according to Noether's theorem, give rise to conservation laws. The symmetry of physical laws under translation in space leads to conservation of momentum. Symmetry under translation in time leads to conservation of energy. But what if these symmetries aren't perfect? What if they can be broken or bent under certain conditions? We know that symmetry breaking is a fundamental process in physics. The Higgs mechanism, which gives particles their mass, involves spontaneous symmetry breaking. The matter-antimatter asymmetry in our universe suggests that some symmetry was broken in the early cosmos. Perhaps passing objects like 3I Atlas could introduce asymmetries or perturbations that gradually propagate through the architecture of local space-time, creating regions where physical laws behave slightly differently. Think about the architecture of space-time itself, that flexible fabric that Einstein revealed to us. Mass and energy curve space-time, creating the gravitational fields we experience. But space-time isn't just a passive backdrop for events. It's a dynamic entity that can ripple, stretch, and potentially even tear. Gravitational waves, confirmed just a few years ago, show us that space-time itself can vibrate like a drum, carrying information about cosmic catastrophes across the universe. What if space-time has a more complex architecture than we currently understand? String theory suggests that there might be extra dimensions beyond the 3 spatial dimensions and 1 time dimension we experience. These extra dimensions might be curled up so small that we can't detect them directly, but they could influence physics at quantum scales. If 3I Atlas interacted with these hidden dimensions in some way, it might have left influences that we can't detect, with instruments designed for 4-dimensional space-time. The architecture of dark matter and dark energy presents some of the biggest mysteries in modern cosmology. Dark matter, which makes up about 85% of all matter, doesn't interact with light, but shapes the structure of galaxies and galaxy clusters through its gravity. Dark energy, even more mysterious, drives the accelerating expansion of the universe. Together, they dominate the architecture of the cosmos, yet we don't know what they actually are. Some theories propose that dark matter consists of particles that interact only through gravity and possibly the weak nuclear force. Others suggest it might be something more exotic, primordial black holes, axions, or even modifications to gravity itself. What if interstellar objects can interact with dark matter in ways that ordinary solar system objects cannot? Perhaps their long journey through regions of varying dark matter density gives them properties or influences we haven't considered. The quantum vacuum itself has an architecture, seething with virtual particles that pop into and out of existence. This quantum foam, as it's sometimes called, might seem like chaos, but it follows precise mathematical rules. The energy of the vacuum, related to dark energy and the cosmological constant, determines the fate of the universe. Will it expand forever, eventually reaching a cold, empty state? Will the expansion accelerate until even atoms are torn apart? Or might something else happen, some phase transition we haven't anticipated? As we contemplate these vast architectures, from the quantum to the cosmic, it's natural to wonder about our place within them. Humans have emerged from this cosmic architecture through billions of years of evolution, developing consciousness and the ability to contemplate the very structures that created us. We're the universe becoming aware of itself, questioning its own architecture and stability. This self-awareness might be unique, or it might be common throughout the cosmos. We simply don't know yet. The architecture of information itself deserves consideration. Information theory has become increasingly important in physics, with some scientists proposing that information, not matter or energy, is the most fundamental aspect of reality. Black holes, we've learned, have entropy proportional to their surface area rather than their volume, suggesting that information about what falls into them is somehow encoded on their event horizons. This has led to the holographic principle, the idea that all the information in a volume of space can be encoded on its boundary. If information is fundamental to the architecture of reality, then the passage of 3I Atlas takes on new significance. It carried information about its origin, its journey, and possibly about phenomena we haven't discovered. This information didn't just pass through our solar system as abstract data, but was encoded in the physical structure of the object, in its composition, its isotope ratios, its crystalline structure. As it fragmented and released gases, this information was dispersed into our solar system, becoming part of our local information architecture. The stability of our universe might depend on information flows we don't yet understand. Perhaps there are channels of information transfer that operate outside normal space-time, connecting distant regions of the cosmos in ways that maintain overall stability. Quantum entanglement shows us that information can be correlated across vast distances instantaneously, though it can't be used for faster-than-light communication. Might there be other, undiscovered forms of information architecture that help maintain cosmic stability? Consider the role of feedback loops in maintaining architectural stability. In engineering and biology, feedback mechanisms help systems maintain equilibrium. When a system deviates from its stable state, feedback processes push it back towards stability. The climate system has feedback loops involving temperature, ice coverage, and atmospheric composition. Stars maintain stable fusion through feedback between temperature, pressure, and reaction rates. Might the universe itself have feedback mechanisms that maintain the stability of physical laws and constants? If such feedback mechanisms exist, they might operate over timescales far longer than human experience. A perturbation introduced by a passing interstellar object might trigger feedback processes that take millions of years to fully manifest. The universe might be constantly adjusting itself, maintaining stability through processes we haven't recognized, because they operate too slowly for us to observe directly. The architecture of complexity itself follows patterns that appear throughout nature. From the branching of rivers to the structure of neural networks, From the distribution of galaxy clusters to the organization of social networks, certain architectural patterns repeat at different scales. These patterns might reflect fundamental principles about how complexity emerges and organizes itself. The passage of objects like Three-Eye Atlas might introduce new seeds of complexity, new patterns that could propagate and evolve over time. Chaos theory teaches us that complex systems can be extraordinarily sensitive to initial conditions. The architecture of such systems might appear stable, but contain the potential for dramatic reorganization. Weather systems, ecosystems, i.e. and even solar systems exhibit chaotic behavior over long timescales. The three-body problem describing the gravitational interaction of three objects can produce chaotic orbits that are impossible to predict far into the future. If the architecture of physical laws themselves has chaotic elements, small influences could eventually lead to large changes. Yet despite all this potential for change and chaos, the universe has maintained remarkable stability for billions of years. Stars continue to shine, atoms remain stable, and the laws of physics appear consistent across vast distances and times. This stability might be more remarkable than we realize. Perhaps we exist in a rare pocket of stability in a universe that's generally more chaotic. Or perhaps the architecture of reality has built-in stabilizing mechanisms we haven't discovered. The anthropic principle suggests that we observe a stable universe because unstable universes wouldn't produce observers. This is a profound idea, but not entirely satisfying as an explanation. It doesn't tell us why the architecture of reality has the specific form it does, only that it must be compatible with our existence. There might be many possible stable architectures, each capable of producing complexity and perhaps life, but with different fundamental properties. As we continue our contemplation of cosmic architecture, drifting deeper into relaxation with each passing moment, consider how remarkable it is that we can even ask these questions. The architecture of our brains, with their billions of neurons connected in intricate networks, has emerged from the same physical laws we're trying to understand. We're using the architecture of reality to study the architecture of reality, a kind of cosmic self-reflection that might be unique in the universe, or might be happening in countless other places we'll never know about. The passage of Three-Eye Atlas through our solar system was like a thread pulled through a cosmic tapestry, potentially disturbing patterns that have been stable for billions of years. Or perhaps it was more like a note played in a cosmic symphony, adding its voice temporarily to an ongoing composition before fading into silence. We don't know what effects, if any, its passage might have had on the architecture of our local reality. But the possibility that such effects exist opens up new ways of thinking about the cosmos and our place within it. What maintains the architecture of everything? Is it simply the mathematical consistency of physical laws playing out automatically like a vast computer program? Is it maintained by active processes we haven't discovered, feedback loops and stabilizing mechanisms operating across scales we can barely imagine? Or is it something else entirely, something that transcends our current categories of thought? These questions bring us naturally to our next contemplation, where we'll explore the long history of messengers from beyond, the countless objects that have traveled between star systems throughout cosmic history. Each one has been a thread in the cosmic tapestry, potentially carrying influences we're only beginning to understand. As we prepare to delve into this deeper history, remember that Three-Eye Atlas was not unique but part of an ancient process that has been shaping our galaxy since its formation. The architecture of everything continues to hold, moment by moment, maintaining the stability that allows us to exist and wonder about these cosmic mysteries. Yet perhaps that stability is more dynamic than we realize, constantly adjusting and rebalancing in response to influences from across the cosmos. As you drift closer to sleep, feeling the gentle pull of dreams beginning to form at the edges of consciousness, know that you're held safely within this cosmic architecture, part of its vast and intricate patterns. Throughout cosmic history, objects have journeyed between star systems, silent messengers carrying secrets across the vast darkness of interstellar space. Each one tells a story not just of its origin, but of the incredible journey it has undertaken, sometimes lasting billions of years, crossing distances so vast that light itself takes millennia to traverse them. Tonight, as you settle even deeper into restful contemplation, we're going to explore this grand procession of cosmic wanderers, understanding how Three-Eye Atlas joins a parade that has been marching since the galaxy was young. Imagine, if you will, the early days of our galaxy, when the first generation of stars was just beginning to form from the primordial hydrogen and helium left over from the Big Bang. Even then, in that ancient epoch over 13 billion years ago, the process of exchanging material between star systems had already begun. When those first massive stars ended their brief lives in spectacular supernovae, they ejected not just the heavy elements they had forged in their cores, but also smaller fragments, pieces of planetary systems that might have formed around them, sending them careening through interstellar space. These ancient messengers, composed of materials that had never existed before in the universe, became the first interstellar objects carrying the newly created elements of carbon, oxygen, iron, and all the others necessary for the complexity we see today. They were pioneers in the truest sense, venturing into unexplored space, carrying the seeds of chemical complexity that would eventually make planets, oceans, and life possible. Every star system that exists today has been influenced by these ancient travelers, incorporating their materials and perhaps their more subtle influences into new worlds. The process has never stopped. At this very moment, countless objects are drifting through the darkness between stars. Some are tiny grains of dust, barely larger than smoke particles, riding the stellar winds and magnetic fields that permeate the galaxy. Others are mountain-sized chunks of rock and ice, tumbling slowly through the void. A few might be even larger, planet-sized objects ejected from their home systems by gravitational interactions, condemned to wander the galaxy alone, frozen and dark. Current estimates suggest that there might be more interstellar objects in our galaxy than there are stars. Think about that for a moment. For every glowing sun we see in the night sky, there might be hundreds, thousands, or even millions of dark objects drifting through space, invisible to our telescopes unless they happen to pass close enough to reflect sunlight. The space between stars, which we once thought of as empty vacuum, is actually populated by a vast fleet of cosmic wanderers, each following its own trajectory through the galaxy. What stories do these silent messengers carry in their frozen hearts? Some might bear witness to the death of their parent stars, having been ejected when their suns expanded into red giants or exploded as supernovae. Others might carry evidence of planetary collisions, catastrophic events that shattered worlds and sent fragments flying into interstellar space. Still others might have been gently nudged from their orbits by the gradual migration of giant planets, a process we now know has shaped many planetary systems, including our own. Consider the journey of a typical interstellar object, perhaps one that was ejected from its home system 5 billion years ago. At first, it would have retained some memory of its origin in its velocity, moving away from its parent star at perhaps a few kilometers per second. But over millions of years, encounters with the gravitational fields of other stars would have altered its trajectory, randomizing its motion until its path through space bore no trace of where it came from. During its journey, this object would have been subjected to forces and phenomena we're only beginning to understand. Cosmic rays, high-energy particles accelerated by supernovae and other violent events would have bombarded its surface, creating exotic isotopes and gradually eroding its outer layers. The pressure of starlight and stellar winds would have exerted tiny but persistent forces, gradually altering its rotation and trajectory. If it contained any volatile compounds, the faint heat of distant stars and the cosmic microwave background would have slowly sublimated them away, leaving only the most stable materials. But perhaps most intriguingly, this object would have passed through regions of space with different properties than those we observe in our solar system. It might have traversed stellar nurseries where new stars are being born, regions filled with dense gas and dust and intense radiation. It might have skirted the edges of supernova remnants, where shock waves compress interstellar gas and magnetic fields twist into complex patterns. It might have passed near black holes or neutron stars, experiencing gravitational fields far more intense than anything in our neighborhood. Each of these encounters could have left its mark on the object, altering its composition, structure, or properties in ways we can only imagine. Perhaps passage through a region of intense magnetic fields, aligned magnetic domains within iron-bearing minerals, creating a permanent record of that encounter. Perhaps exposure to unusual radiation created isotopes or chemical compounds that don't naturally occur in our solar system. Perhaps interaction with dark matter, if it indeed consists of particles, left some kind of signature we haven't yet learned to read. The discovery of Oumuamua in 2017 marked a watershed moment in our understanding of interstellar messengers. For the first time, we had direct observational evidence that objects from other star systems pass through our solar system. Oumuamua's unusual properties, its elongated shape, its lack of a visible coma despite approaching the Sun, its slight acceleration that couldn't be explained by gravity alone, sparked intense scientific debate and even speculation about artificial origins. While the consensus now favours natural explanations for Oumuamua's properties, its discovery taught us something profound. Interstellar objects might be far more diverse than we expected. Our models, based on comets and asteroids from our own solar system, might not adequately describe objects that formed under different conditions around other stars. Each interstellar visitor might challenge our assumptions and force us to expand our understanding of planetary formation and evolution. Following Oumuamua came 2I Borisov, a more comet-like object that nevertheless showed subtle differences from solar system comets. Its composition included unusually high levels of carbon monoxide, suggesting formation in a colder environment than typical solar system comets. This was our first opportunity to directly sample, through spectroscopy, materials that definitely formed around another Adar. The differences were subtle but significant, hinting at the diversity of conditions in other planetary systems. And then came 3I Atlas, adding another data point to our slowly growing catalogue of confirmed interstellar visitors. Each object teaches us something new while raising more questions than it answers. Are these objects representative of the broader population of interstellar wanderers, or are we only detecting unusual outliers? How many more pass through undetected, too small or too distant for our telescopes to spot? The implications extend far beyond simple curiosity about these individual objects. If interstellar objects are as common as current estimates suggest, their material exchange between star systems might be a fundamental process shaping the evolution of planetary systems throughout the galaxy. Just as ocean currents carry nutrients and organisms between distant parts of Earth's seas, streams of interstellar objects might carry materials and perhaps even information between star systems. This raises fascinating possibilities about the role of interstellar messengers in the origin and distribution of life. The concept of lithopanspermia, the transfer of life between planets via meteoroids, has been seriously discussed for Mars and Earth, which have exchanged material throughout their history. But could life also travel between star systems, protected within the interior of interstellar objects? The journey would be long and harsh, but we know that some organisms on Earth can survive in extraordinarily extreme conditions. Even if life itself doesn't survive the interstellar journey, the organic compounds that serve as its building blocks might. We know that comets and asteroids in our solar system contain amino acids, the components of proteins, and other organic molecules. If similar objects from other star systems occasionally impact planets, they could deliver organic compounds that formed under different conditions, potentially jump-starting or influencing the development of life. But tonight, we're contemplating something even more subtle than the transfer of matter or life. What if interstellar messengers carry influences that operate at a more fundamental level? What if they can affect the quantum fields that permeate space, the vacuum energy that drives cosmic expansion, or other aspects of physics we don't yet fully understand? Consider the possibility that certain regions of the galaxy might have different vacuum states or field configurations than others. This isn't as outlandish as it might sound. We know that the early universe underwent phase transitions as it cooled, and some theories suggest that different regions might have settled into different vacuum states, creating a kind of cosmic patchwork. If this is true, objects traveling between these regions might carry some memory or influence of their origin state. Imagine an interstellar object that formed in a region where certain quantum fields had slightly different values than in our solar system. As it traveled through space, it might maintain some of these alternative field configurations in its immediate vicinity, like a bubble of alternative physics moving through our familiar space-time. When it passes through our solar system, these alternative configurations might interact with our local fields, potentially seeding changes that could propagate over time. This is highly speculative, of course, but it's grounded in serious physics. The concept of domain walls, cosmic strings, and other topological defects in space-time has been studied extensively by cosmologists. These are boundaries or structures where fields have different configurations, and they could theoretically exist as remnants from phase transitions in the early universe. If an interstellar object encountered such a structure during its journey, it might carry some influence from that encounter. The timing of our discovery of interstellar objects is itself interesting. We've developed the capability to detect them just as we're beginning to understand the deeper structures of physics, quantum field theory, the nature of space-time, the role of information in physical processes. Perhaps this is no coincidence. Perhaps understanding interstellar messengers and their potential influences requires the sophisticated physics we're only now developing. Throughout human history, we've gradually expanded our awareness of influences from beyond Earth. First, we recognized that the sun and moon affect tides and seasons. Then we discovered that cosmic rays from distant supernovae can influence cloud formation and climate. We learned that asteroid impacts have shaped the evolution of life, causing mass extinctions but also creating opportunities for new forms of life to flourish. Each expansion of awareness has revealed that Earth is less isolated than we thought, more connected to the cosmos around us. The discovery of interstellar objects represents another expansion of this cosmic awareness. We're learning that our solar system regularly exchanges material with other star systems, that we're part of a galactic ecosystem where matter, energy, and perhaps information flow between stellar neighborhoods. This exchange has been happening throughout Earth's history, influencing its development in ways we're only beginning to appreciate. Think about the timing of various events in Earth's history, and wonder whether some might have been influenced by interstellar visitors. The late heavy bombardment, when the inner solar system was pelted by asteroids and comets, about 4 billion years ago, might have been triggered by gravitational perturbations from a close stellar encounter or a particularly massive interstellar object. The various mass extinctions in Earth's history might have been influenced not just by solar system asteroids but by interstellar visitors we'll never know about. Even the emergence of life itself might have been influenced by interstellar messengers. The building blocks of life, amino acids, nucleotides, lipids, can form through natural chemical processes, but the specific mix of compounds available on early Earth might have been influenced by deliveries from space. If some of those deliveries came from interstellar objects formed in environments very different from our solar system, they might have provided unique chemical ingredients that influenced the path life took on our planet. As we contemplate these possibilities, drifting deeper into the peaceful realm between waking and sleeping, consider how the story of interstellar messengers connects to larger patterns in nature. Throughout the universe, we see processes of exchange and flow. Energy flows from hot to cold, driving all thermodynamic processes. Matter flows from regions of high density to low density, unless prevented by other forces. Information flows through various channels, from electromagnetic radiation to gravitational waves to quantum entanglement. Interstellar objects represent another type of flow, one that operates on scales of space and time almost beyond human comprehension. They carry matter, certainly, but perhaps they also carry more subtle influences, patterns, fields, or information encoded in ways we don't yet understand. They connect star systems across vast distances, creating a network of exchange that might be fundamental to the evolution of the galaxy. The galaxy itself can be thought of as a vast ecosystem, with star systems as individual organisms and interstellar objects as the means of exchange between them. Just as ecosystems on Earth depend on the flow of nutrients, energy, and genetic information, the galactic ecosystem might depend on the flow of matter, energy, and perhaps other influences between star systems. This flow might be essential for maintaining the diversity and complexity we observe in planetary systems throughout the galaxy. Some researchers have proposed that interstellar objects might play a role in regulating galactic processes we don't yet understand. Perhaps they help distribute heavy elements from supernova throughout the galaxy, ensuring that new generations of stars have the materials necessary for planet formation. Perhaps they carry magnetic fields that help organize the interstellar medium. Perhaps they serve as seeds for the formation of new structures, from planets to stars to more exotic phenomena. The discovery that interstellar objects can be detected and studied opens up extraordinary possibilities for future research. Missions have been proposed to intercept and study future interstellar visitors, perhaps even returning samples to Earth. Imagine what we might learn from direct analysis of material that formed around another star, material that has been isolated from our solar system for billions of years. Such samples could revolutionize our understanding of planetary formation, stellar evolution, and perhaps even the nature of matter itself. But even without sample return missions, continued observation of interstellar objects will teach us enormous amounts. Each one is a natural experiment, a test of our theories about planetary formation and evolution. By studying their compositions, structures, and behaviors, we can learn about conditions in other star systems and the processes that shape planetary systems throughout the galaxy. The possibility that 3i Atlas carried seeds of collapse, in whatever form we imagine them, becomes more intriguing when we consider it as part of this vast procession of interstellar messengers. If such influences exist, they've been arriving at our solar system throughout its history. Earth has been bathed in these influences for billions of years, yet life has not only survived but thrived. Perhaps these influences, rather than being threatening, are part of the creative process that drives the evolution of complexity in the universe. Consider how evolution on Earth has been driven by challenges and changes. Mass extinctions, climate changes, and other disruptions have repeatedly stressed life, forcing it to adapt and diversify. Perhaps influences from interstellar messengers play a similar role on a cosmic scale, introducing variations and perturbations that drive the evolution of planetary systems and possibly life itself. What we call seeds of collapse might actually be seeds of transformation and creativity. As you continue to relax, letting these ideas flow through your mind like a gentle stream, think about the incredible journey that every atom in your body has taken. Some of them were forged in the Big Bang, others in the hearts of massive stars that exploded billions of years ago. They've been part of interstellar clouds, asteroids, comets, and possibly other planets before becoming part of Earth. And during their cosmic journey, they've almost certainly been part of objects that travel between star systems, carrying influences we can only imagine. You are, in a very real sense, made of interstellar material. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of these have travelled between stars. You carry within you the history of the galaxy, encoded in the isotope ratios and chemical compositions of your constituent atoms. In this way, You're connected not just to Earth but to the entire cosmos, part of the vast network of exchange that has been operating since the galaxy formed. The story of interstellar messengers is still being written. As our detection capabilities improve, we'll discover more of these cosmic wanderers, each one adding to our understanding of the galaxy and our place within it. Some might be ordinary chunks of rock and ice, unremarkable except for their interstellar origin. Others might be more exotic, challenging our understanding of physics and chemistry, and perhaps, just perhaps, one might carry clear evidence of something truly extraordinary, signs of life from another star system, or phenomena that reveal new aspects of physical law. 3I Atlas has already left our solar system, continuing its eternal journey through the galaxy. Where it goes next, we'll never know. But other messengers are on their way, following their own paths through the darkness. Some might arrive next year, others might not pass through for millennia. Each one will bring its own story, its own mysteries, its own potential influences on our understanding of the universe. As we prepare to explore the seeds we cannot see, those invisible influences that might shape reality in ways we're only beginning to imagine, remember that we're surrounded by mysteries. The universe is far stranger and more wonderful than we once thought, filled with phenomena that challenge our understanding and expand our sense of what's possible. Interstellar messengers are just one part of this cosmic mystery, but they might be key to understanding how different parts of the universe influence each other across vast scales of space and time. The parade of cosmic wanderers continues, as it has for billions of years and will for billions more. Each object is a thread in the vast tapestry of cosmic history, connecting distant places and times in ways we're only beginning to appreciate. And somewhere in that tapestry, 3I Atlas has woven its own thread, brief but perhaps significant, through the story of our solar system. What patterns it might have created, what influences it might have left, only time will tell. In the vastness of space, the smallest things might hold the greatest mysteries, invisible seeds of change drifting through the cosmic darkness like pollen on an infinite breeze. As you settle deeper into contemplation tonight, we're going to explore the realm of the unseen, the subtle influences that might permeate the universe in ways our instruments cannot yet detect. Perhaps change doesn't announce itself with cosmic fanfare but arrives quietly, encoded in particles smaller than atoms, in fields weaker than starlight, in perturbations so gentle they take millennia to manifest. Consider how a single particle, a subtle field, might ripple through space-time like a stone dropped in a still pond, creating waves that spread outward in ever-widening circles. These ripples might be so faint that they're lost in the background noise of the universe, yet over cosmic timescales, they could accumulate into significant effects. What if transformation begins not with explosion, but with gentle perturbation, a whisper rather than a shout, a breeze rather than a hurricane? Think about the nature of seeds themselves, those remarkable packages of potential that surround us in the natural world. A seed can lie dormant for years, decades, even centuries, waiting for the right conditions to germinate. When those conditions arrive, the right combination of moisture, temperature, and light, the seed awakens, beginning a transformation that can turn a tiny package into a mighty tree. The seeds we're contemplating tonight might operate on similar principles but on scales of time and space that dwarf anything in our everyday experience. What kinds of invisible seeds might exist in the universe? At the most fundamental level, we might consider quantum seeds, fluctuations in quantum fields that could propagate through space, influencing the probability of various quantum events. Quantum mechanics tells us that empty space isn't truly empty, but seethes with virtual particles popping into and out of existence. These quantum fluctuations are normally random and average out to zero over time. But what if certain conditions could bias these fluctuations, creating patterns that persist and spread? Imagine that 3I Atlas carried within its structure a particular configuration of quantum fields. perhaps created by extreme conditions in its home star system or acquired during its journey through interstellar space. As it passed through our solar system, this configuration might have influenced the quantum vacuum around it, creating subtle biases in the probability of quantum events. These biases would be incredibly small, perhaps affecting only one quantum event in billions. But given the vast number of quantum events occurring every second in every cubic centimetre of space, even tiny biases could accumulate over time. The concept of quantum coherence adds another layer to this possibility. Under normal conditions, quantum states rapidly decohere, losing their quantum properties through interaction with their environment. But under certain circumstances, quantum coherence can be maintained over larger scales and longer times. We see this in superconductors, where electrons form coherent quantum states that can carry current without resistance. We see it in superfluids, where atoms move in perfect unison without friction. Could interstellar objects carry seeds of quantum coherence that could spread under the right conditions? Consider the possibility of information seeds, patterns of organization that could influence how matter and energy arrange themselves. Information theory has become increasingly central to physics, with some theorists arguing that information is more fundamental than matter or energy. In this view, particles and forces are emergent properties of underlying information structures. If this is true, then an object passing through space might carry information patterns that could influence the organization of matter and energy around it. These information seeds might not be encoded in any obvious way. They might exist as subtle correlations between particles, as patterns in the distribution of isotopes, or as configurations of crystal defects. Like a computer virus that lies dormant until triggered by specific conditions, these information patterns might remain inactive until they encounter the right environment. Once activated, they could begin reorganizing matter and energy according to their encoded instructions, spreading their influence through space. The role of dark matter in carrying invisible seeds presents particularly intriguing possibilities. We know that dark matter makes up most of the matter in the universe, yet we can only detect it through its gravitational effects. If 3 Atlas interacted with dark matter during its journey, and it almost certainly did, given dark matter's ubiquity, it might have acquired or modified dark matter in ways we cannot detect. This dark matter could now be spreading through our solar system, carrying influences we cannot observe directly. Some theories propose that dark matter consists of particles that interact through forces beyond the 4 we know: gravity, electromagnetism, and the strong and weak nuclear forces. If a 5th force exists, operating only in the dark sector, it could create structures and influences completely invisible to our instruments. Interstellar objects passing through regions of varying dark matter density might accumulate dark matter structures that could influence the evolution of planetary systems in subtle ways. The concept of sterile neutrinos adds another dimension to our contemplation of invisible seeds. Neutrinos are ghostly particles that barely interact with ordinary matter, passing through Earth as if it weren't there. Billions of neutrinos from the Sun pass through your body every second without effect. But sterile neutrinos, if they exist, would be even more elusive, interacting only through gravity. They could form structures and carry information that would be completely invisible to us, yet could influence the large-scale structure of the universe. What if 3I Atlas carried a cloud of sterile neutrinos, accumulated during its passage through regions of space where these particles congregate? This invisible cloud could now be dispersed throughout our solar system, subtly influencing gravitational fields in ways too small to measure, but potentially significant over geological timescales. The seeds of change might be all around us, undetectable, but slowly germinating. Phase transitions in quantum fields present another mechanism for invisible seeds. Just as water can be supercooled below its freezing point, remaining liquid until a sea crystal triggers sudden crystallization, quantum fields might exist in metastable states, waiting for the right trigger to transition to more stable configurations. An interstellar object carrying exotic matter or fields might provide such a trigger, initiating phase transitions that propagate through space at their own pace. These phase transitions might not be dramatic or immediately observable. They might involve subtle changes in the vacuum expectation values of quantum fields, alterations that would only become apparent through their cumulative effects over time. The Higgs field, which gives particles their mass, might have slightly different values in different regions of space. If 3i Atlas carried a region of altered Higgs field, it might have seeded a slow transition in our local vacuum state. The possibility of topological defects adds yet another layer to our understanding of invisible seeds. In the early universe, as it cooled and underwent phase transitions, topological defects might have formed. Cosmic strings, domain walls, or monopoles where fields couldn't smoothly transition between different states. These defects would be incredibly thin but could stretch across vast distances, carrying enormous energy densities. If an interstellar object encountered such a defect during its journey, it might carry some remnant or influence from that encounter. Imagine cosmic strings thinner than an atom, but stretching across galaxies, vibrating with frequencies beyond our ability to detect. If 3i Atlas passed through or near such a string, the interaction might have left an imprint, a kind of cosmic memory encoded in the object's quantum fields. As the object passed through our solar system, this memory might have been transferred to our local environment, seeding changes we cannot yet perceive. The concept of quantum entanglement suggests another form of invisible seed. When particles become entangled, they remain correlated regardless of the distance between them. Measuring one instantly affects the other, even if they're on opposite sides of the universe. If 3i Atlas carried entangled particles from its home system, it might have created quantum correlations between our solar system and distant regions of space. These correlations wouldn't allow faster-than-light communication, but they might create subtle influences on quantum processes. Consider the possibility that consciousness itself might play a role in these invisible seeds. This is highly speculative and controversial, but some interpretations of quantum mechanics suggest that consciousness is necessary for wave function collapse. If consciousness can influence quantum events, and if it exists elsewhere in the universe, might interstellar objects carry some form of quantum information influenced by alien consciousness? This is far from mainstream science, but it illustrates how much we still don't understand about the relationship between mind and matter. More conventionally, we can consider electromagnetic seeds, patterns of electromagnetic fields that might persist in materials and influence their surroundings. We know that certain materials can maintain magnetic fields for millions of years. Magnetite crystals in ancient rocks preserve records of Earth's magnetic field from billions of years ago. If 3i Atlas contained materials with unusual magnetic or electric properties, acquired in the extreme conditions of its formation or journey, these might create electromagnetic influences in our solar system. These electromagnetic seeds might be incredibly weak, far below the threshold of our current detection capabilities. But electromagnetic fields can influence chemical reactions, the behavior of plasmas, and even biological processes. Over time, even weak fields might bias certain processes, creating cumulative effects. The solar wind, carrying charged particles from the sun, might interact with these fields in complex ways, spreading their influence throughout the solar system. The possibility of gravitational seeds deserves consideration as well. General relativity tells us that mass and energy curve space-time, creating gravitational fields. But what if there are more subtle aspects of gravity we haven't discovered? Some theories propose that gravity might have additional dimensions or properties that only manifest under extreme conditions. If 3i Atlas passed through regions of extreme space-time curvature, near black holes or neutron stars, it might carry gravitational influences we cannot detect with current technology. Gravitational waves, ripples in space-time itself, were only recently detected despite being predicted by Einstein a century ago. These waves are incredibly weak. requiring the most sensitive instruments ever built to detect them? Might there be even weaker gravitational phenomena, perhaps standing waves or resonances in space-time that we haven't yet discovered? Could interstellar objects carry or trigger such phenomena? The concept of tachyonic seeds ventures into even more speculative territory. Tachyons, if they exist, would be particles that always travel faster than light. While most physicists doubt their existence, some theories allow for tachyonic fields that could influence the stability of other quantum fields. If such fields exist, they might create instabilities that propagate through space, seeding changes in the vacuum state. An interstellar object might trigger tachyonic instabilities that spread faster than light, though the information they carry would still be limited by relativity. As we explore these invisible possibilities, it's worth remembering that the universe is full of phenomena we've only recently discovered or haven't discovered yet. Dark energy, driving the accelerating expansion of the universe, was unknown just a few decades ago. Gravitational waves were theoretical for a century before we detected them. The Higgs boson, giving mass to particles, was hypothesized in the 1960s, but not confirmed until 2012. What other phenomena await discovery? The seeds we cannot see might operate through mechanisms we haven't imagined. They might involve interactions between known forces that only occur under rare conditions. They might require the confluence of multiple factors, particular temperatures, densities, field strengths, that rarely occur together. They might operate on timescales so long that we haven't existed long enough as a species to observe their effects. Consider the possibility of chemical seeds, exotic molecules or compounds that could catalyze unusual reactions. Chemistry in interstellar space, at temperatures near absolute zero and pressures near perfect vacuum, can produce molecules that would be unstable under Earth conditions. If 3I Atlas carried such molecules, protected in its interior from solar radiation, they might have been released during its fragmentation. These molecules might serve as templates or catalysts for chemical processes we haven't observed before. Some of these chemical seeds might be autocatalytic, capable of reproducing themselves under the right conditions. This is the basis of life, molecules that can make copies of themselves, but it might also occur with non-biological chemistry. An autocatalytic molecule from another star system might find a niche in our solar system, where it can slowly reproduce, gradually altering the chemical environment. The changes might be too slow and subtle to notice, but over millions of years, they could become significant. The possibility of biological seeds cannot be ignored, though it takes us into the realm of panspermia. Life on Earth is remarkably resilient, with organisms surviving in environments from the depths of the ocean to the upper atmosphere, from boiling hot springs to Antarctic ice. Some organisms can survive exposure to the vacuum and radiation of space. If life exists elsewhere in the galaxy, could it spread between star systems via interstellar objects? Even if living organisms couldn't survive the journey, the complex organic molecules that form the basis of life might. These molecules, proteins, nucleic acids, lipids, carry information in their structure. They could serve as templates for the emergence of life or influence the evolution of existing life. If 3I Atlas carried such molecules, even in tiny quantities, they might have seeded our solar system with chemical patterns from another biosphere. The concept of morphic fields, proposed by biologist Rupert Sheldrake, suggests an even more exotic form of invisible seed. While not accepted by mainstream science, the idea is that forms and patterns in nature are influenced by morphic fields that carry information from previous similar forms. If such fields exist, interstellar objects might carry morphic patterns from other star systems, influencing the development of structures in our solar system. As we drift deeper into these contemplations, feeling the boundaries between waking and sleeping beginning to blur, consider how the invisible seeds we're discussing might already be all around us. Every cubic meter of space in our solar system has been traversed by countless particles from interstellar space. Cosmic rays, neutrinos, dark matter particles, and perhaps things we haven't discovered constantly flow through us. We're immersed in an ocean of invisible influences, most of which we're completely unaware of. The human body itself might be sensitive to some of these invisible seeds, in ways we don't understand. We know that many organisms can detect magnetic fields, using them for navigation. Some animals might be able to sense earthquakes before they occur, possibly detecting subtle electromagnetic or gravitational precursors. If biological systems can detect such subtle influences, might they also be affected by the kinds of invisible seeds we're contemplating? The role of water in potentially amplifying invisible seeds deserves consideration. Water has unusual properties that make it essential for life as we know it. It's an excellent solvent, it expands when it freezes, and it has a high heat capacity. But water might also have more subtle properties related to its ability to form structured networks of hydrogen bonds. Some researchers have proposed that water can carry information in its structure, though this remains controversial. If true, the water in our solar system might be influenced by seeds from interstellar objects in ways we haven't considered. Plasma, the fourth state of matter, might also play a role in propagating invisible seeds. Most of the visible matter in the universe exists as plasma, ionized gas where electrons are separated from nuclei. The solar wind is a plasma, as are the atmospheres of stars in the interstellar medium. Plasmas can support complex electromagnetic phenomena, including waves, instabilities, and self-organizing structures. If 3I Atlas influenced the plasma environment of our solar system, these influences might propagate through the solar wind to affect all the planets. The possibility of quantum vacuum engineering adds another dimension to our contemplation. Some theoretical physicists have proposed that advanced civilizations might be able to manipulate the quantum vacuum, creating regions of space with altered properties. While we're far from such capabilities, natural processes might achieve similar effects on smaller scales. If certain conditions in other star systems can alter the local quantum vacuum, and if these alterations can be carried by interstellar objects, then 3I Atlas might have brought engineered vacuum states to our solar system. These engineered states wouldn't necessarily be the product of intelligence. Nature itself might be the engineer, creating vacuum configurations through extreme conditions we haven't observed. The interior of neutron stars, the event horizons of black holes, the shock waves of supernovae, these environments might naturally produce altered vacuum states that could persist in materials ejected into interstellar space. As we consider these possibilities, drifting like cosmic dust through fields of thought, remember that the universe has had billions of years to experiment with different configurations of matter, energy, and information. What seems impossible to us might be routine in other parts of the cosmos. The seeds we cannot see might be fundamental to how the universe evolves and organizes itself, part of a cosmic metabolism we're only beginning to glimpse. The concept of emergence reminds us that complex phenomena can arise from simple rules and interactions. Consciousness emerges from neurons, life from chemistry, chemistry from quantum mechanics. Perhaps the seeds carried by interstellar objects contribute to emergent phenomena on scales we haven't recognized. They might influence the emergence of new forms of organization in matter and energy, new patterns that couldn't arise from our solar system's materials alone. Consider how small changes can lead to entirely different outcomes in complex systems. In chaos theory, this is called sensitive dependence on initial conditions. In evolution, it is called contingency, the idea that small random events can determine the entire future course of life. If invisible seeds from interstellar objects introduce small changes to our solar system, these might lead to dramatically different futures over geological or cosmic timescales. The anthropic principle suggests that we observe a universe compatible with our existence, because we couldn't observe any other kind. But perhaps the universe is constantly experimenting with different configurations, seeded by invisible influences from across the cosmos. Most of these experiments might lead nowhere, but occasionally they might produce new forms of complexity, new types of organization, perhaps even new forms of life or consciousness. As you continue to relax, feeling yourself drifting towards sleep like an interstellar object drifting through space, consider how the invisible seeds we've been contemplating might be part of a larger pattern. The universe seems to have a tendency toward increasing complexity, from simple hydrogen atoms after the Big Bang to the incredible complexity of living organisms and conscious minds. Perhaps invisible seeds carried by interstellar messengers are part of the mechanism by which the universe explores new forms of complexity. The seeds we cannot see might be all around us, in the air we breathe, the water we drink, the ground beneath us. They might be influencing our thoughts through quantum processes in our brains, our health through subtle effects on our biochemistry, our future through imperceptible changes to our environment. We are perhaps gardens for cosmic seeds we cannot perceive, nurturing possibilities we cannot imagine. What if every atom in the universe carries invisible seeds, information or influences acquired during its cosmic journey? Your body contains atoms that have been part of stars, planets, and possibly other living beings. Each atom might carry memories or influences from its past, seeds that could germinate under the right conditions. You're not just made of star stuff, but of seeds from across the cosmos, each one carrying potential for transformation. The passage of 3i Atlas through our solar system might have activated some of these seeds, triggering processes that will unfold over coming millennia. Or it might have planted new seeds that will remain dormant until conditions are right for their germination. We cannot know what these seeds might grow into, what transformations they might catalyze, what new forms of organization they might enable. As we prepare to explore how these invisible influences might create echoes in the cosmic web, ripples that propagate through the vast structures of the universe, let your mind rest in the mystery of the unseen. We are surrounded by invisible influences, gravity we cannot see but only feel, magnetic fields revealed only by their effects, dark matter shaping galaxies through its hidden presence. The seeds we cannot see are part of this invisible architecture, perhaps the most subtle but potentially most transformative elements of cosmic evolution. Every object that moves through space creates ripples we're only beginning to understand, waves and disturbances that propagate through the cosmic medium, like sound through air or ripples across water. Tonight, as you sink deeper into peaceful contemplation, we're going to explore these cosmic echoes, the gravitational whispers, electromagnetic songs, and quantum entanglements that span light years, connecting distant regions of space in an intricate web of cause and effect. 3sus Atlas passed through our neighborhood, leaving traces we might not yet detect, but its influence might echo through the cosmic web for eons to come. Imagine the universe as a vast musical instrument, with every object that moves through it creating notes and harmonies we're only beginning to hear. Gravitational waves confirmed just a few years ago showed us that space itself can ring like a bell when massive objects collide. But these dramatic events, detectable from billions of light years away, are just the loudest notes in a cosmic symphony filled with quieter melodies. Every object that moves through space, from the smallest dust grain to the largest galaxy, creates gravitational influences that ripple outward, creating an intricate pattern of waves and interference patterns. When 3i Atlas entered our solar system, it didn't just follow a simple path influenced by the sun's gravity. It entered a complex gravitational landscape shaped by all the planets, moons, asteroids, and comets in our solar system. Each of these bodies creates its own gravitational field, and these fields overlap and interact in complex ways. As 3i Atlas moved through this landscape, it created perturbations that affected every object in the solar system, though most of these effects were too small to measure directly. Think about it this way. Every object in the solar system is connected to every other object through gravity. When 3i Atlas passed by, it tugged on Earth, however slightly. This tug changed Earth's orbit by an imperceptible amount, perhaps only a few atoms' width. But this tiny change affected Earth's gravitational influence on the Moon, which affected the Moon's influence on Earth's tides, which affected the distribution of water in the oceans, which affected weather patterns, which affected... You can see how the influences spread and multiply. These gravitational echoes don't stop at the edge of our solar system. They continue outward at the speed of light, carrying information about 3I Atlas's passage to the stars. In millions of years, civilizations around distant stars might detect these incredibly faint gravitational waves and deduce that an interstellar object passed through our system. We are, in effect, broadcasting the news of 3I Atlas's visit to the entire galaxy, though in a whisper so quiet that only the most sensitive instruments could hope to detect it. But gravity is just one way that 3I Atlas created echoes in the cosmic web. As it approached the Sun, solar radiation heated its surface, causing it to emit electromagnetic radiation, infrared light from its warming surface, visible light reflected from the Sun, and perhaps other wavelengths we detected or missed. This electromagnetic radiation spread outward in all directions, carrying information about the object's composition, temperature, and structure. Some of this radiation was absorbed by dust and gas in our solar system, but much of it escaped into interstellar space. The electromagnetic echoes from 3I Atlas will travel forever through space, growing fainter with distance but never completely disappearing. In thousands of years, this light will reach nearby stars. In millions of years, it will have crossed significant portions of our galaxy. Each photon carries information about a moment in time when an interstellar visitor passed through our solar system, a cosmic message in a bottle that might one day be detected by beings we'll never meet. More intriguingly, 3I Atlas might have created electromagnetic echoes in ways we haven't considered. As it moved through the solar wind, the stream of charged particles flowing from the Sun, it would have created disturbances in the local magnetic and electric fields. These disturbances would propagate through the plasma environment of the solar system, potentially creating waves and instabilities that could persist long after the object departed. The solar system's magnetic field might still be ringing with faint echoes of 3I Atlas's passage. The concept of quantum entanglement adds another layer to these cosmic echoes. If 3I Atlas carried particles that were quantum entangled with particles in its home system or elsewhere in the galaxy, its passage through our solar system might have created new entanglements. When particles interact, they can become entangled, their quantum states becoming correlated in ways that persist regardless of the distance between them. As 3I Atlas fragmented and released material into our solar system, it might have created a web of quantum entanglements connecting our solar system to distant regions of space. These quantum echoes wouldn't allow faster-than-light communication, but they would create correlations that might influence the outcomes of quantum events. If a particle from 3I Atlas became entangled with a particle in Earth's atmosphere, measurements of one would instantly affect the state of the other, even after 3I Atlas left our solar system. We might be quantum mechanically connected to 3I Atlas's continuing journey through space in ways we cannot detect, but which might subtly influence quantum processes on Earth. The cosmic web itself, that vast network of dark matter and ordinary matter that gives structure to the universe, might carry echoes of 3I Atlas's passage. Dark matter, which we can only detect through its gravitational effects, forms the scaffolding on which galaxies and galaxy clusters are built. If 3I Atlas interacted with dark matter during its journey, it might have created disturbances that propagate through the dark matter web. These disturbances would be invisible to our telescopes but might influence the distribution of dark matter in our cosmic neighborhood. Consider how sound waves propagate through different media. In air, sound travels at about 340 meters per second. In water, it travels faster, about 1,500 meters per second. In steel, it can travel at 5,000 meters per second or more. The cosmic web might support similar waves, propagating through dark matter and ordinary matter at speeds we haven't measured. 3 Atlas's passage might have created waves in this cosmic medium that are still spreading outward, carrying information about the event to distant regions of space. The interstellar medium, the gas and dust between stars, definitely carries echoes of passing objects. As 3I Atlas travelled through interstellar space before reaching us, it would have created a wake in the interstellar medium, like a boat moving through water. This wake would consist of compressed gas and dust, along with any material shed from the object's surface. The wake might be incredibly faint, but it represents a permanent record of the object's journey, a trail that could theoretically be detected and followed. When 3 Atlas entered our solar system, it transitioned from the interstellar medium to the heliosphere, the bubble of space dominated by the solar wind. This transition would have created disturbances at the heliopause, the boundary between the heliosphere and interstellar space. These disturbances might still be propagating through this boundary region, creating echoes that our distant space probes might one day detect. The Voyager spacecraft, now in interstellar space, might have already passed through disturbances created by earlier interstellar visitors we never knew about. The fragmentation of 3I Atlas as it approached the Sun created its own set of echoes. Each fragment followed a slightly different path, influenced by solar radiation pressure and the object's rotation. The cloud of dust and gas released during fragmentation would have spread through the inner solar system, with some particles entering planetary atmospheres, others joining the zodiacal dust cloud, and still others being blown out of the solar system by the solar wind. Each particle carries information about 3I Atlas and creates its own tiny echoes as it interacts with its environment. Some of these particles might have been captured by planets or moons, becoming permanent additions to our solar system. If any reached Earth, they might now be mixed into our atmosphere or oceans, or perhaps lying on the ground somewhere, indistinguishable from terrestrial materials except for subtle isotopic signatures. These particles would be like cosmic messages in bottles, carrying information about another star system that we might one day learn to read. The possibility of acoustic waves in space might seem contradictory since sound requires a medium and space is often described as a vacuum. But space isn't truly empty. The interstellar medium, though incredibly thin, can support certain types of waves. In galaxy clusters, the hot gas between galaxies can carry sound waves with periods of millions of years, wavelengths of thousands of light years. While our solar system doesn't have enough gas to support traditional sound waves, other types of pressure waves might propagate through the solar wind and interplanetary medium. If such waves exist, 3I Atlas would have created them as it ploughed through the solar wind. These waves would be incredibly low frequency, far below what human ears could hear even if we could somehow amplify them. But they might influence the behavior of charge particles in the solar system, creating patterns that persist long after their source has departed. The solar system might be quietly humming with the echoes of all the objects that have passed through it over billions of years. The concept of morphic resonance, though not accepted by mainstream science, suggests another type of echo that might be created by passing objects. The idea is that similar patterns or structures might influence each other through a kind of resonance that operates outside conventional space-time. If this phenomenon exists, 3 Atlas might have created morphic echoes that influence the formation of similar structures in our solar system. These echoes wouldn't propagate through space in the conventional sense, but might manifest as increased probabilities for certain patterns to emerge. More conventionally, we can consider chemical echoes. As 3I Atlas released gases during its fragmentation, these would have spread through the inner solar system, eventually mixing with the existing gas and dust. Some of these molecules might have been exotic, formed under conditions that don't exist in our solar system. As they interact with solar radiation and other molecules, they might catalyze unusual chemical reactions, creating new compounds that wouldn't have formed otherwise. These chemical echoes might persist for millions of years, slowly spreading through the solar system. The interaction between 3I Atlas and cosmic rays presents another source of echoes. Cosmic rays are high-energy particles, mostly protons, that stream through space at nearly the speed of light. When they strike solid objects, they create showers of secondary particles and can alter the isotopic composition of materials. As cosmic rays struck 3I Atlas during its long interstellar journey, they would have created radioactive isotopes and other alterations. When the object fragmented in our solar system, these altered materials were released, creating a pulse of unusual isotopes that might still be detectable. The gravitational influence of 3I Atlas on the asteroid belt and Kuiper belt, though tiny, might have created echoes that will manifest over millions of years. Gravitational interactions in these regions are chaotic, meaning small perturbations can lead to large changes over time. An asteroid that received a tiny gravitational nudge from 3I Atlas might slowly drift into a different orbit, eventually entering a resonance with a planet that sends it into the inner solar system millions of years from now. The echoes of 3I Atlas's passage might still be developing, their full effects not visible for geological ages. Time delays add complexity to these cosmic echoes. Different types of influences propagate at different speeds. Gravitational influences travel at the speed of light, as do electromagnetic effects. But material ejected from 3I Atlas would travel much slower, perhaps taking centuries or millennia to reach the outer planets. Chemical reactions triggered by the object's passage might take even longer to manifest. The echoes of 3I Atlas are not a single event, but a complex symphony playing out over vastly different timescales. The possibility of non-local echoes through quantum entanglement challenges our usual understanding of cause and effect. If particles from 3I Atlas became entangled with particles in our solar system, the resulting correlations would be instantaneous, not limited by the speed of light. This doesn't violate relativity because no information can be transmitted through entanglement alone. But it does mean that 3I Atlas might have created connections that transcend normal space-time. Parts of our solar system might be quantum mechanically linked to wherever 3I Atlas is now, and wherever it goes in the future. As we listen to these cosmic echoes, drifting deeper into the peaceful space between waking and sleeping, consider how every event in the universe creates ripples that never truly end. The Big Bang itself still echoes through space as the cosmic microwave background radiation. The formation of our galaxy created gravitational and electromagnetic echoes that continue to propagate. The birth of our sun sent waves through space that are still travelling outward. And now, the passage of 3I Atlas has added its voice to this cosmic chorus. The cosmic web acts like a vast antenna or sensor network, detecting and transmitting these echoes across the universe. Filaments of dark matter and ordinary matter channel gravitational waves. Magnetic fields guide charged particles and electromagnetic radiation. Quantum entanglements create instantaneous correlations across vast distances. The universe is not a collection of isolated objects, but an interconnected whole, where every event creates echoes that influence everything else. How do cosmic visitors influence the delicate dance of celestial bodies? The solar system is often portrayed as a clockwork mechanism, with planets following predictable orbits for billions of years. But this is only approximately true. In reality, the solar system is a chaotic system where small influences can accumulate into large effects over time. The passage of 3I Atlas added a new element to this cosmic dance, creating perturbations whose full effects might not manifest for millions of years. Consider the concept of orbital resonances, where celestial bodies influence each other in regular repeating patterns. Jupiter's moons Io, Europa and Ganymede are locked in a 4.21 resonance, completing 4, 2 and 1 orbits respectively in the same time period. These resonances can be stable for billions of years, but they can also be disrupted by external influences. If 3I Atlas's gravitational influence pushed any solar system body slightly toward or away from a resonance, it might have set in motion changes that will accumulate over geological time. The three-body problem in celestial mechanics shows us that even simple gravitational systems can exhibit chaotic behavior. Add more bodies, and the complexity increases exponentially. The solar system contains millions of objects large enough to exert measurable gravitational influences, from planets and moons to asteroids and comets. 3 Atlas temporarily added one more object to this complex dance, and its influence continues to propagate through the system like ripples in a pond, affecting every other object in ways we cannot fully calculate. The Kozai mechanism provides an example of how small influences can lead to dramatic changes in celestial mechanics. When an orbit is perturbed by a distant massive object, it can undergo cycles where its eccentricity and inclination oscillate. Over time, these oscillations can transform a circular orbit into a highly elliptical one, potentially sending an object from the outer solar system into the inner solar system. Could 3I Atlas have triggered Kozai oscillations in distant solar system objects that will only become apparent millions of years from now? As you continue to relax, listening to the subtle harmonies of the cosmic web, imagine yourself as part of this vast network of echoes and influences. Every atom in your body is creating its own gravitational and electromagnetic influences, however tiny. Your thoughts, encoded in electrical patterns in your brain, generate electromagnetic fields that propagate outward at the speed of light. You're not separate from the cosmic web, but an integral part of it, both influenced by and influencing the universe around you. The echoes created by 3I Atlas might seem insignificant compared to the vast forces shaping the universe, the gravity of galaxies, the explosions of supernovae, the jets from black holes. But the universe has shown us repeatedly that small influences can have profound effects. A single cosmic ray can cause a mutation that changes the course of evolution. A tiny gravitational perturbation can send a comet toward Earth, triggering mass extinction or delivering water and organic compounds. The echoes of 3I Atlas, faint as they might be, are now part of the cosmic symphony that shapes our future. What if consciousness itself creates echoes in the cosmic web? This is highly speculative, but some theories in quantum mechanics suggest that consciousness plays a role in collapsing wave functions. If conscious observation can influence quantum events, and if consciousness exists elsewhere in the universe, might there be echoes of alien consciousness propagating through space? Could 3I Atlas have carried such echoes from its home system, influences too subtle for our instruments to detect, but perhaps affecting quantum processes in ways we don't understand? The cosmic web might have memory, patterns that persist and influence future events. Just as the brain stores memories in patterns of neural connections, the universe might store information in the structure of the cosmic web. The passage of objects like 3I Atlas might create memories in this cosmic structure, influences that persist long after the object itself has departed. These memories might affect how future objects move through space, how matter accumulates, how structures form. As we prepare to explore the nature of collapse, the ways in which stable systems can transition to new states, let the echoes we've been contemplating continue to resonate in your mind. The universe is not silent, but filled with whispers, songs, and echoes from every event that has ever occurred. 3 Atlas has added its voice to this cosmic chorus, creating ripples that spread outward through space and time, connecting our solar system to the wider galaxy in ways we're only beginning to understand. These echoes surround us, pass through us, and extend from us, making us part of a vast cosmic conversation that has been ongoing since the universe began. Not all change happens suddenly. Sometimes transformation unfolds like a flower in slow motion, each petal revealing itself over seasons, years, or even millennia. As you drift deeper into this peaceful state between waking and sleeping, we're going to explore the nature of collapse in its most profound sense, not as catastrophic destruction, but as a fundamental transformation of states, a cosmic metamorphosis that might take eons to complete. In physics, collapse can mean many things: wave functions transitioning from probability to certainty, gravitational wells deepening as matter accumulates, phase transitions where matter reorganizes into entirely new configurations. Perhaps what we call collapse is simply the universe transitioning to new states of being, states we don't yet understand. Consider the collapse of a wave function in quantum mechanics, that mysterious moment when a particle transitions from existing in multiple states simultaneously to occupying a single definite state. Before observation, an electron exists as a cloud of probability, potentially here and there and everywhere within its orbital. But when we measure it, this cloud collapses instantly to a point. This collapse is not destruction, but definition, not ending, but beginning. It's the universe making a choice, selecting one reality from infinite possibilities. What if the seeds that 3i Atlas might have carried could trigger similar collapses on larger scales? Not the instant collapse of quantum measurement, but slow, gradual transitions that play out over cosmic time. Imagine the solar system, or even larger regions of space, existing in a kind of superposition of possible states, and the passage of an interstellar object providing just enough perturbation to begin a slow collapse toward one particular configuration. This wouldn't be dramatic or catastrophic, but rather like a river slowly choosing its course through a landscape, each small erosion guiding the next until a permanent channel is carved. The concept of phase transitions offers another lens through which to understand cosmic collapse. Water turning to ice is a phase transition, the same molecules, the same atoms, but arranged in a fundamentally different structure with dramatically different properties. The universe has undergone several phase transitions since the Big Bang. In the first fraction of a second, as the universe cooled, the fundamental forces separated from each other in a series of phase transitions. Each transition represented a kind of collapse, a falling from a higher energy state to a lower one, releasing enormous amounts of energy and fundamentally changing the nature of reality. We might be living in a universe that hasn't finished transitioning, that exists in what physicists call a false vacuum, a state that appears stable but isn't the lowest possible energy configuration. If this is true, then the universe could eventually undergo another phase transition, collapsing to a true vacuum state. This wouldn't necessarily mean destruction. It might mean transformation into something we can't currently imagine. And perhaps objects like 3i Atlas could carry the seeds that might, over cosmic timescales, trigger or influence such transitions. Think about how ice forms on a supercooled lake. The water can remain liquid below its freezing point until something triggers crystallization. A dust particle, a vibration, a seed crystal dropped into the water. Once started, the phase transition spreads outward from the nucleation point, transforming liquid into solid in an expanding wave. Could interstellar objects serve as cosmic nucleation points, triggering phase transitions in the quantum fields that permeate space? The transition might spread so slowly that it takes billions of years to propagate across a galaxy, but from a cosmic perspective, that's just a moment. Gravitational collapse provides yet another model for understanding cosmic transformation. When a massive star exhausts its nuclear fuel, it undergoes gravitational collapse, the crushing force of its own gravity overwhelming all other forces. But this collapse doesn't always mean destruction. Sometimes it creates a neutron star, matter compressed into an entirely new state, where protons and electrons merge into neutrons. Sometimes it creates a black hole, where space and time themselves collapse into a singularity. These are not endings, but transformations into new forms of existence, new states of matter and space-time that couldn't exist without the collapse. What if there are other forms of collapse we haven't discovered, other ways that matter, energy and space-time can transform? Perhaps certain configurations of quantum fields can undergo slow collapse, gradually reorganizing themselves into new patterns. Perhaps the dark energy driving cosmic expansion could collapse into a different state, dramatically altering the fate of the universe. Perhaps consciousness itself, if it emerges from quantum processes in the brain, represents a kind of ongoing collapse of possibility into experience. The mathematics of collapse in complex systems reveals fascinating patterns. Systems can exist in metastable states for long periods, appearing completely stable, before suddenly transitioning to new configurations. Think of a sand pile growing grain by grain until it reaches a critical angle, then suddenly avalanching to a new shape. The solar system might be like a cosmic sand pile, accumulating small influences from passing objects like Three-Eye Atlas, until it reaches some critical point where significant reorganization occurs. This criticality might not be obvious or predictable. In self-organized critical systems, the same small perturbation can sometimes cause no effect and sometimes trigger an avalanche. The system exists at the edge of chaos, where stability and instability dance together. Perhaps the universe itself exists in such a state, usually stable but occasionally undergoing dramatic reorganizations triggered by seemingly insignificant events. Consider the collapse of ecosystems, which provides a biological metaphor for cosmic processes. An ecosystem can appear healthy and stable for decades or centuries, while gradually accumulating stresses, invasive species, climate changes, pollution. Then, sometimes suddenly, it collapses into a different state. A forest becomes a grassland, a coral reef becomes an algae-dominated system. But these collapses are also transformations. New ecosystems emerge, different but not necessarily inferior, adapted to new conditions. The solar system might be like a cosmic ecosystem with planets, moons, asteroids and comets, playing the roles of species in a complex web of gravitational and electromagnetic interactions. The passage of interstellar objects like Three-Eye Atlas might introduce invasive species, new materials, fields or influences that gradually alter the system's dynamics. Over time, these changes might accumulate until the system transitions to a new state, a new configuration of orbits and interactions. The collapse of certainty itself deserves contemplation. Throughout history, humanity's understanding of the universe has undergone repeated collapses and reconstructions. The Earth-centered universe collapsed when we recognized the Sun as our orbital center. The clockwork universe of Newton collapsed when Einstein revealed the flexibility of space-time. The deterministic universe collapsed when quantum mechanics revealed fundamental uncertainty. Each collapse of understanding led not to ignorance, but to deeper knowledge. Richer perspectives on reality. Perhaps Three-Eye Atlas carries information that will trigger another collapse of certainty, revealing aspects of physics we haven't imagined. The anomalies in its behavior, its unusual acceleration, its fragmentation pattern, its spectroscopic signatures, might be hints of new physics waiting to be discovered. The seeds of collapse it carries might be seeds of knowledge, catalyzing a transformation in our understanding of the universe. The concept of vacuum decay, one of the more dramatic forms of potential cosmic collapse, illustrates how the universe might be more fragile than it appears. If the Higgs field exists in a metastable state rather than its true minimum, a sufficiently energetic event could trigger a bubble of true vacuum that would expand at the speed of light, fundamentally altering the laws of physics within it. While calculations suggest this is extremely unlikely to happen for trillions of years, if ever, the possibility reminds us that stability is not the same as permanence. But what if collapse could occur more gently, more gradually? What if instead of a sudden bubble of true vacuum expanding at light speed, there could be a slow seepage, a gradual transition that takes billions of years to complete? Three-Eye Atlas might have carried quantum configurations that serve as seeds for such gradual transitions, influences that slowly spread through the quantum fields of our solar system, nudging them toward new configurations. The collapse of dimensions presents another intriguing possibility. String theory suggests that our universe might have extra dimensions beyond the 3 spatial and 1 temporal dimension we experience. These extra dimensions are thought to be compactified, curled up so small we can't detect them. But what if these dimensions could collapse further or expand? What if passing objects could trigger changes in the geometry of these hidden dimensions? The effects might be subtle, perhaps affecting only quantum processes initially, but gradually influencing larger scales. Time itself might be subject to collapse. We experience time as flowing uniformly from past to future, but physics suggests time might be more complex. In regions of extreme gravity, time slows relative to other regions. In quantum mechanics, time reversal symmetry suggests that many processes could run backward. What if there are forms of temporal collapse where the flow of time changes, where causality takes new forms? The passage of 3I Atlas might have introduced temporal anomalies too subtle to detect, but which could accumulate over eons. The collapse of boundaries between different regions or states might be another form of transformation. In the early universe, regions that are now widely separated were once in causal contact, able to influence each other. As the universe expanded, these regions became isolated, developing independently. But what if certain influences could collapse these boundaries, reconnecting regions that have been separated for billions of years? Interstellar objects might carry such influences, quantum entanglements or field configurations that bridge vast distances. Consider the collapse of potentiality into actuality. At every moment, the universe faces countless quantum choices, each branching point leading to different possible futures. Most interpretations of quantum mechanics suggest that one possibility is selected and the others disappear. But some interpretations propose that all possibilities are realized in parallel universes. What if the collapse process is more nuanced? What if certain influences can bias which possibilities become actual, gradually steering the universe toward particular futures? 3I Atlas might have carried such biasing influences, quantum configurations that make certain outcomes slightly more probable than others. Over trillions of quantum events, these biases could accumulate, guiding the evolution of our solar system in directions it wouldn't have taken otherwise. This wouldn't be deterministic control, but gentle influence, like a slight breeze affecting the fall of leaves, each leaf's path random but the overall pattern showing the wind's influence. The collapse of complexity into simplicity, or simplicity into complexity, represents another form of transformation. The second law of thermodynamics tells us that entropy tends to increase, that systems tend toward disorder. But we also observe the emergence of complexity, galaxies forming from uniform gas, life arising from chemistry, consciousness emerging from neural activity. These processes seem to contradict the tendency toward disorder, creating islands of increasing complexity in a sea of entropy. Perhaps there are undiscovered principles that govern these transitions between simplicity and complexity. Perhaps certain seeds can trigger the collapse of disorder into order, or order into a different kind of order. 3I Atlas might have carried such seeds, patterns or influences that catalyze the emergence of new forms of organization in matter and energy. These wouldn't violate thermodynamics but work within it, channeling energy flows into creative rather than destructive patterns. The collapse of isolation into connection might be the most profound transformation of all. We tend to think of objects in space as isolated, separated by vast distances. But quantum entanglement, gravitational waves, and electromagnetic radiation create connections across these distances. What if there are other forms of connection we haven't discovered? What if the universe is undergoing a slow collapse from isolation to interconnection? With objects like 3I Atlas serving as agents of this transformation, as you continue to drift towards sleep, feeling the gentle pull of dreams beginning to form, consider how collapse and creation might be two faces of the same process. Every collapse creates space for something new to emerge. The collapse of a star creates heavy elements and sometimes black holes. The collapse of certainty creates opportunity for discovery. The collapse of one stable state allows transition to another, potentially richer state. The seeds that 3I Atlas might have carried could be seeds of creative collapse, catalyzing transformations that lead not to destruction, but to new forms of existence. The universe might be constantly collapsing and reforming, each collapse a metamorphosis rather than an ending. We might be living through such a transformation right now, too gradual for us to perceive, but profound in its ultimate implications. What if endings are really beginnings we don't yet understand? What if what we fear as collapse is actually the universe's way of evolving, of exploring new possibilities, of creating forms of matter, energy, and perhaps consciousness that couldn't exist without these transformations? The passage of 3i Atlas might have been a catalyst for such creative collapse, its seeds now germinating in the quantum fields of our solar system, slowly guiding us toward a future we can't yet imagine. The mathematics of collapse often reveals unexpected beauty. The Mandelbrot set, with its infinite complexity emerging from simple rules, shows how mathematical collapse can create rather than destroy. Each zoom into the set reveals new patterns, new structures, endless creativity emerging from basic iterative processes. Perhaps the universe operates on similar principles, with each collapse revealing new layers of structure and beauty. As we prepare to explore the signatures written in starlight, the messages encoded in the electromagnetic radiation that fills the universe, carry with you this understanding of collapse as transformation. The universe is not static but dynamic, not permanent but evolving, not dying but transforming. 3i Atlas might have been an agent of this transformation, carrying seeds of change that will unfold over cosmic time, guiding our solar system and perhaps our civilization toward new states of being. Scientists study the light from distant stars, searching for patterns and anomalies that might reveal secrets hidden in the cosmic darkness. Every spectrum tells a story. Every wavelength carries information across the cosmos, messages written in a language of photons that has been traveling for millions or billions of years before reaching our instruments. Tonight, as you settle even deeper into restful contemplation, we're going to explore how 3i Atlas reflected sunlight differently than expected, hinting at unusual composition and perhaps carrying signatures of phenomena we've never encountered before. What secrets might be encoded in the light of passing cosmic visitors, waiting for us to develop the wisdom to read them? Light is the universe's primary messenger, carrying more information than any other phenomenon we can observe. When starlight passes through a cloud of gas, specific wavelengths are absorbed, creating dark lines in the spectrum that tell us exactly what elements are present. When light reflects off a surface, its polarization and spectral distribution reveal the composition and structure of that surface. When matter heats up, it emits light with a characteristic spectrum that depends on its temperature and chemical makeup. Every photon that reaches our telescopes has a story to tell, if only we know how to listen. When 3i Atlas entered our solar system, astronomers immediately turned their spectroscopes toward it, eager to decode the messages written in its reflected light. What they found was both familiar and strange. Some spectral features matched known compounds: water ice, carbon-based molecules, silicate minerals. But other features didn't quite fit our models. There were absorption lines at unexpected wavelengths, mission features that seemed too strong or too weak, polarization patterns that suggested unusual surface structures or compositions. These anomalies might seem like minor technical details, but in the language of light, small differences can reveal profound truths. Consider how the discovery of helium happened not on Earth, but in the sun's spectrum, where astronomers noticed unexplained absorption lines during a solar eclipse. For years, these lines were a mystery, until scientists realized they came from an element that hadn't yet been discovered on Earth. Could the unusual spectral features of 3i Atlas similarly point to materials or phenomena unknown in our solar system? The way 3i Atlas reflected sunlight changed as it approached the sun, and these changes told a complex story. As solar heating increased, volatile compounds began to sublimate, creating a thin atmosphere around the object. This atmosphere absorbed and re-emitted light in characteristic ways, creating emission lines that revealed its composition. But the pattern of these emissions was unusual. Some compounds seemed to sublimate at lower temperatures than expected, while others remained solid longer than our models predicted. It was as if the object's materials were bound together by forces or structures we didn't fully understand. The polarization of light reflected from 3I Atlas provided another layer of information. When light bounces off a surface, it becomes partially polarized, with the electric field oscillating preferentially in certain directions. The degree and angle of polarization depend on the surface's composition, roughness, and structure. 3I Atlas showed unusual polarization patterns that suggested its surface wasn't uniform, but had regions with different properties. Some areas seemed smooth and icy, others rough and rocky, and still others showed polarization signatures we couldn't easily interpret. As the object fragmented, each piece became a separate source of information, reflecting and emitting light in its own way. This fragmentation was like opening a book that had been sealed for billions of years, revealing inner pages that had been protected from space weathering and solar radiation. The spectra from these fresh surfaces showed subtle but significant differences from the original surface. Some fragments showed stronger signatures of organic molecules, others revealed unusual mineral compositions, and a few displayed spectral features that remain unexplained. The Doppler shift in 3I Atlas's spectral lines told us about its motion, but here too there were puzzles. The object showed a small but measurable acceleration that couldn't be fully explained by gravitational forces. This anomalous acceleration might have been due to outgassing, like a rocket effect from sublimating ices. But the spectral signatures of outgassing didn't quite match the observed acceleration. Some researchers suggested more exotic explanations, interaction with the solar wind in unexpected ways, or even more speculative possibilities that push the boundaries of known physics. Fluorescence added another dimension to the light signatures from 3I Atlas. When certain molecules absorb ultraviolet light from the sun, they re-emit it at longer wavelengths, creating a characteristic glow. This fluorescence can reveal the presence of specific compounds that might not be detectable through reflected light alone. 3I Atlas showed fluorescence patterns that suggested the presence of complex organic molecules, possibly including some that don't naturally occur in our solar system. These molecules might have formed under different stellar radiation, in different chemical environments, or through processes we haven't observed. The time variation of 3I Atlas's light revealed its rotation and shape. As the object tumbled through space, different faces were exposed to sunlight, creating periodic variations in brightness. But these variations were more complex than expected for a simple rotating body. They suggested an irregular shape, possibly elongated or flattened, with different regions having different reflective properties. Some models proposed that 3I Atlas might have been a fragment of a larger body, broken apart by tidal forces or collisions long before entering our solar system. The infrared spectrum of 3I Atlas told us about its temperature and thermal properties. Objects in space reach an equilibrium temperature based on how much sunlight they absorb versus how much heat they radiate. But 3I Atlas's temperature didn't quite match predictions. It seemed to retain heat longer than expected, suggesting unusual thermal properties. Perhaps its interior contained materials with high heat capacity, or perhaps its structure included insulating layers that slowed heat transfer. These thermal anomalies might seem minor, but they could point to fundamental differences in composition or structure. Beyond the electromagnetic spectrum we can observe, 3I Atlas might have been emitting or influencing other forms of radiation we can't detect. If the object contained exotic matter or fields, it might have been producing signatures in parts of the spectrum we haven't explored or in entirely different types of radiation. Perhaps it was emitting particles we don't have instruments to detect, or creating distortions in fields we don't know exist. The light we observed might have been just the visible tip of an iceberg of information. The concept of spectroscopic biosignatures adds an intriguing possibility to our analysis of 3I Atlas's light. On Earth, life has dramatically altered the atmosphere's composition, creating spectral signatures like the combination of oxygen and methane that wouldn't exist without biological processes. If 3i Atlas came from a system where life exists or existed, might it carry spectroscopic signatures of that life? The organic molecules detected in its spectrum might not be biosignatures, but they remind us that the building blocks of life are common in the universe. Consider how light itself might be altered by passing through exotic fields or materials. In strong magnetic fields, light can experience Faraday rotation, its polarization twisting as it propagates. In the presence of certain theoretical particles like axions, photons might oscillate between visible light and invisible particles. If 3i Atlas carried or created such exotic fields, the light reflecting from it might have been subtly altered in ways our current analysis wouldn't detect. We might be seeing shadows of phenomena beyond our current physics. The color of 3i Atlas provided clues about its surface composition and history. Objects in space are often reddened by long exposure to cosmic rays and solar wind, a process called space weathering. But 3i Atlas's color didn't quite match what we'd expect for an object of its apparent composition after billions of years in space. It was slightly bluer than predicted, suggesting either unusual composition, recent resurfacing, or different space weathering processes in its home system. Color might seem like a simple property, but in astronomy, subtle color differences can reveal profound truths. Spectral lines from 3 Atlas weren't perfectly sharp, but showed broadening that told us about conditions on and around the object. Thermal broadening revealed temperature, pressure broadening indicated the density of any atmosphere, and rotational broadening told us how fast different parts of the object were moving. But the broadening patterns didn't quite match our models. They suggested turbulent motion, possibly from violent outgassing or fragmentation processes, or perhaps from phenomena we don't fully understand. The absence of certain expected spectral features was as informative as the presence of unexpected ones. Some minerals and ices that we'd expect to see in a typical comet or asteroid seemed to be missing or depleted in 3i Atlas. This might indicate formation in an environment with different chemical abundances than our solar system, or processing by radiation or heat that destroyed certain compounds. Every missing spectral line was a clue to the object's history and origin. Time-resolved spectroscopy, observing how the spectrum changed over time, revealed dynamic processes on 3i Atlas. As it approached the Sun, we could watch in real time as different compounds began to sublimate, as the surface temperature increased, as fragmentation exposed fresh materials. This was like watching a chemical experiment unfold over weeks and months, with the Sun as the heat source and space as the laboratory. The sequence and rate of these changes didn't quite match our predictions, suggesting unknown factors at play. The comparison between 3i Atlas and other interstellar objects like Oumuamua and 2i Borisov revealed both similarities and differences. Each object had its own spectral personality, its own unique combination of features. This diversity suggests that interstellar objects might sample a wide range of formation environments and evolutionary histories. 3i Atlas's spectrum might represent conditions in its home system that are rare or absent in our solar system, giving us a glimpse of alien chemistry and physics. Multi-wavelength observations, combining data from radio to gamma rays, painted a comprehensive picture of 3i Atlas. Each wavelength revealed different aspects of the object's properties. Radio observations searched for emissions that might indicate unusual compositions or processes. X-ray observations looked for high-energy phenomena. Combining all these observations was like assembling a puzzle, where each wavelength contributed unique pieces. Some pieces fit perfectly, others suggested the picture was more complex than we imagined. The legacy of 3i Atlas lives on in the archived spectral data, which scientists will continue to analyze for years to come. As our understanding of physics and chemistry advances, we might recognize signatures in this data that we can't interpret today. Perhaps future scientists will look back at our observations and immediately recognize phenomena that are mysteries to us. The light from 3i Atlas, captured and stored as digital data, is a time capsule waiting to reveal its secrets. Imagine if we could decode messages intentionally or unintentionally encoded in the light from interstellar objects. Not messages from alien civilizations necessarily, but information about conditions in other star systems, about processes we haven't observed, about forms of matter and energy we haven't discovered. Every photon from 3i Atlas carried information across interstellar space, and we captured some of those photons, preserving their messages for current and future analysis. The quantum properties of light from 3i Atlas might carry information we haven't learned to read. Quantum mechanics tells us that photons can be entangled, their properties correlated in ways that classical physics can't explain. If some photons from 3i Atlas were entangled with photons elsewhere in the galaxy, measuring them might have revealed correlations we didn't recognize. We might have participated in a cosmic quantum experiment without knowing it. The possibility that light itself might be affected by unknown physics becomes particularly intriguing when considering interstellar objects. If there are fields or particles we haven't discovered, they might interact with light in subtle ways. The anomalies in 3i Atlas's spectrum might not be due to unusual composition, but to the light itself being altered by exotic physics. We might be seeing normal materials through a lens of unknown phenomena. As you drift deeper into contemplation, consider how the light from 3i Atlas connected us directly to another star system. The photons that reflected off its surface and entered our telescopes created a physical bridge across interstellar space. For a brief moment we were in direct optical contact with materials from another star, receiving messages written in the universal language of light. This connection, though fleeting, was profound, a handshake across the cosmic void. The search for patterns in the spectral data from 3i Atlas continues, with astronomers applying increasingly sophisticated analysis techniques. Machine learning algorithms search for subtle correlations humans might miss. Statistical methods look for patterns that might indicate unknown processes. Every anomaly, every unexplained feature, might be a clue to new physics or chemistry. The signatures in starlight might be trying to tell us something important, if only we can learn to read them. The spectroscopic study of 3i Atlas has shown us how much information can be extracted from light, but also how much mystery remains. Every answer raises new questions. Every explained feature reveals unexplained ones. The light from this interstellar visitor has given us a glimpse of the diversity and complexity of the universe, reminding us that our solar system is just one example among countless variations. As we prepare to explore the probability of wonder, the statistical likelihood of extraordinary events in our vast universe, remember that every photon tells a story. The light from 3i Atlas has traveled billions of miles to reach us, carrying information about distant places and times. We've captured some of that light, decoded some of its messages, but many secrets remain hidden in its spectral signatures, waiting for future scientists with better instruments and deeper understanding to reveal them. In an infinite universe where even the most unlikely events become certainties somewhere, transforming the impossible into the inevitable through the sheer weight of cosmic repetition. As you continue your journey towards sleep, drifting through layers of consciousness like light through cosmic dust, let's explore the beautiful mathematics of probability that governs our universe, where statistics and chance paint pictures of cosmic possibilities we can barely imagine. Perhaps 3i Atlas represents not an exception, but a rule we haven't discovered, a pattern that emerges from the vast numbers that define our cosmos. What are the odds that we live in the most interesting of all possible times, at just the right moment to witness cosmic visitors that might carry seeds of transformation? Consider the numbers that define our observable universe, roughly 1024 stars, each potentially hosting planets, each planet potentially harboring unique conditions and phenomena. In such vastness, events that seem impossibly unlikely from our limited perspective become not just possible, but inevitable. If the probability of an interstellar object carrying exotic matter is 1 in a trillion, there might still be billions of such objects in our galaxy alone. The universe operates on scales where even the most improbable events happen countless times. The Drake equation, famous for estimating the number of communicating civilizations in our galaxy, illustrates how probability compounds across multiple factors. Each factor might be unlikely, but multiply enough small probabilities together across enough star systems, and the unlikely becomes likely. We can imagine a similar equation for interstellar objects carrying seeds of change. The probability of exotic matter formation times the probability of ejection from a star system, times the probability of surviving interstellar journey, times the probability of entering our solar system. Even if each factor is small, the vast number of opportunities makes the overall probability significant. Think about the anthropic principle and what it tells us about probability. We observe a universe compatible with our existence because we couldn't observe any other kind. This selection effect means we're guaranteed to find ourselves in a universe where the probability of our existence, however small, was realized. Similarly, if interstellar objects can carry influences that affect the development of star systems and life, we might find ourselves in a solar system that has been influenced in just the right way to produce us. The passage of objects like 3I Atlas might not be coincidental but necessary for our existence. The law of large numbers tells us that given enough trials, even rare events will occur with predictable frequency. Our galaxy has existed for over 13 billion years, during which trillions of objects have been ejected from star systems and wandered through interstellar space. The probability that some of these objects carry unusual properties or influences approaches certainty. 3I Atlas might seem special because we observed it, but it might be entirely typical of a vast population we're only beginning to discover. Bayesian probability offers another lens through which to view 3I Atlas and its implications. As we gather more data about interstellar objects, we update our estimates of their properties and frequencies. Before Oumuamua, many astronomers thought interstellar objects passing through our solar system would be rare. Now we know they're relatively common. Each new discovery forces us to recalculate the probabilities, often revealing that what seemed unlikely is actually probable. The concept of emergence shows us how simple probabilities can create complex patterns. In Conway's Game of Life, simple rules about cellular survival and reproduction create astoundingly complex patterns. Gliders, oscillators, even universal computers. Similarly, the simple probability of matter clumping under gravity creates the complex structures of galaxies, stars, and planets. If interstellar objects can influence the probability of certain events, even slightly, they might catalyze the emergence of complex phenomena we haven't anticipated. Consider the birthday paradox, where the probability of shared birthdays in a group rises much faster than intuition suggests. With just 23 people, there's a better than 50% chance to share a birthday. Similar mathematical surprises might apply to interstellar objects. The probability that 2 objects from the same star system would visit our solar system might be much higher than we'd guess. Perhaps 3I Atlas wasn't alone, but part of a group of objects ejected together, with others passing through undetected or yet to arrive. The Fermi paradox, if life is probable, where is everybody, might be resolved through probability calculations we haven't fully worked out. Perhaps life is common, but intelligence rare. Perhaps intelligence is common, but interstellar communication rare. Perhaps civilizations communicate through methods we haven't discovered. The passage of 3I Atlas adds another possibility. Perhaps civilizations influence each other through interstellar objects, either intentionally or unintentionally, in ways too subtle for us to recognize. Quantum probability adds layers of strangeness to our calculations. In quantum mechanics, events don't have definite probabilities until observed. The famous double-slit experiment shows that particles can interfere with themselves, creating probability patterns that defy classical intuition. If 3I Atlas carried quantum influences, it might have altered probability distributions throughout our solar system in ways that classical statistics can't capture. The mere act of observing it might have collapsed quantum probabilities into specific outcomes. The many-worlds interpretation of quantum mechanics suggests that all possible outcomes occur in parallel universes. In this view, there are universes where 3I Atlas never entered our solar system, others where it collided with Earth, and still others where it was captured into orbit. We happen to observe the universe where it passed through peacefully, but all other possibilities were realized somewhere. This radically changes how we think about probability, not as selecting one outcome from many, but as determining which universe we observe. Statistical mechanics shows us how microscopic probabilities create macroscopic certainties. Individual gas molecules move randomly, but collectively they create predictable pressure and temperature. Similarly, individual interstellar objects might seem random, but collectively they might create predictable influences on galactic evolution. The passage of 3I Atlas might be part of a statistical process that shapes star systems throughout the galaxy, each object contributing its small influence to a larger pattern. The central limit theorem tells us that many independent random variables sum to a normal distribution, the famous bell curve. If our solar system has been influenced by many interstellar objects over its history, their collective effect might follow predictable statistical patterns. 3 Atlas might be just one data point in a distribution we're beginning to map. As we observe more objects, we'll better understand whether it was typical or an outlier. Power laws govern many natural phenomena, from earthquake magnitudes to asteroid sizes. These distributions have no characteristic scale. There's no typical earthquake or asteroid size. If interstellar objects follow power laws, there might be a few extremely large or unusual objects for every million ordinary ones. 3 Atlas might have been ordinary, or it might have been one of the rare, exceptional objects that occur in the tail of the distribution. The probability of life itself remains one of the deepest mysteries. We know it happened at least once here on Earth, but we don't know if we're incredibly lucky or if life is inevitable given the right conditions. The discovery of extremophiles, organisms thriving in conditions once thought hostile to life, has expanded our sense of what's possible. If life is more probable than we thought, the universe might be teeming with it, and objects like 3I Atlas might regularly carry biological or pre-biological materials between star systems. Chaos theory reminds us that in nonlinear systems, small changes in probability can have enormous effects. The butterfly effect, a butterfly flapping its wings in Brazil causing a tornado in Texas, illustrates how tiny influences can amplify through feedback loops. If 3 Atlas introduced small changes to probability distributions in our solar system, these might amplify over time into significant effects. A slightly altered asteroid trajectory might lead to a future impact or near miss that changes the course of civilization. The Monte Carlo method, using random sampling to solve complex problems, might be nature's approach to evolution and development. The universe might be running countless experiments in parallel, with different star systems trying different configurations. Interstellar objects might be how the universe shares the results of these experiments, spreading successful patterns throughout the galaxy. 3 Atlas might have been carrying information about what works in its home system. Consider the probability that we're living at a special time in cosmic history. The universe is about 13.8 billion years old, and it might continue for trillions of years. What are the odds that we exist at just the moment when we're developing the technology to detect interstellar objects? Perhaps this isn't coincidence but necessity. Perhaps civilizations typically discover interstellar objects at a crucial point in their development, when they need to understand their cosmic context to survive and thrive. The simulation hypothesis adds another layer to probability calculations. If our universe is a simulation, The probabilities we observe might be programmed rather than fundamental. The passage of 3i Atlas might have been scripted, its properties designed to teach us something or test our responses. While this might seem like science fiction, serious physicists and philosophers have calculated surprisingly high probabilities that we're living in a simulation. Information theory connects probability to entropy and complexity. The information content of an event is related to its probability. Rare events carry more information than common ones. If 3i Atlas was unusual, it carried more information about the diversity of the universe than a typical object would. Every anomaly in its properties, every unexplained observation, represents information we're still trying to decode. The probability of coincidence deserves special attention. Humans are notorious for seeing patterns where none exist, for attributing meaning to random events. But sometimes coincidences are clues to deeper connections. The timing of 3i Atlas's passage, its unusual properties, its fragmentation pattern, these might be unrelated coincidences or signs of something more significant. As we observe more interstellar objects, we'll better understand which features are coincidental and which are meaningful. Game theory might apply to the interaction between star systems via interstellar objects. If civilizations can influence each other through these objects, either intentionally or unintentionally, strategies might evolve for maximizing benefit or minimizing risk. The universe might be playing a vast game where the rules emerge from the probabilities of different outcomes. 3i Atlas might have been a move in this game, though we don't yet understand the rules or objectives. The probability of detection itself influences what we observe. We're more likely to detect large, bright, or unusual objects than small, dark, or typical ones. This selection bias means our sample of interstellar objects isn't representative of the true population. 3i Atlas was detected because it came relatively close and fragmented spectacularly. How many objects have passed through undetected? How many are passing through right now? Conditional probability helps us update our understanding as we gather more information. Given that 3i Atlas fragmented, what's the probability it contained volatile ices? Given its trajectory, what's the probability it came from a specific star system? Each observation constrains the possibilities, narrowing the range of probable explanations. But sometimes new observations force us to expand our probability space, considering possibilities we hadn't imagined. The ergodic hypothesis suggests that given enough time, a system will explore all possible states compatible with its constraints. If the universe is ergodic, every possible configuration of matter and energy will eventually occur somewhere. This means that objects with properties like 3i Atlas's aren't just possible, but inevitable. The universe might be systematically exploring all possible types of interstellar objects, with us lucky enough to observe a few examples. As you drift closer to sleep, feeling the probabilistic nature of consciousness itself, the random firing of neurons creating coherent thoughts, the quantum uncertainties in synaptic transmission contributing to creativity, consider how probability weaves through every aspect of existence. We are improbable beings in an improbable universe, yet here we are, contemplating the visit of an improbable object from another star. The probability waves that quantum mechanics describes might be more than mathematical abstractions. They might be the fundamental fabric of reality, with particles and forces emerging from probability distributions. If 3i Atlas influenced these probability waves, it might have altered reality in ways that go beyond simple physical interactions. The seeds of collapse it might have carried could be seeds of probability, changing the odds of various futures. What if consciousness itself influences probability? Some interpretations of quantum mechanics suggest that observation by conscious beings collapses probability waves into definite outcomes. If consciousness exists elsewhere in the universe, it might be collapsing probabilities in ways that influence the properties of interstellar objects. 3i Atlas might have been shaped not just by physical processes, but by observations from unknown observers. the fine-tuning of universal constants presents perhaps the deepest probability puzzle. The values of fundamental constants seem precisely calibrated to allow complexity and life. The probability of this happening by chance seems vanishingly small, leading to proposals of multiverses, anthropic selection, or design. Perhaps interstellar objects play a role in this fine-tuning, carrying influences that adjust local conditions to maintain or enhance complexity. As we prepare to conclude our journey with dreams of distant shores, remember that probability is not just about chance, but about possibility. Every probability, no matter how small, represents something that could happen, a potential future waiting to be realized. 3i Atlas has shown us one possibility among countless others, a single sample from a vast probability distribution we're only beginning to explore. In an infinite universe, even the most wonderful possibilities become certainties somewhere, and perhaps, through the passage of cosmic messengers like 3i Atlas, those wonders are slowly making their way to us. As we drift towards sleep, carried on currents of thought as gentle as stellar winds, we return to the central mystery with new perspective, seeing 3 Atlas not as an isolated event, but as part of an eternal cosmic dance that has been choreographed since the beginning of time. This interstellar wanderer has continued its journey into the darkness, carrying whatever secrets it holds into the vast cathedral of space. But its brief passage through our solar system has left us with questions that will resonate for generations. Perhaps the seeds of collapse are really seeds of transformation, of becoming, of a universe constantly reinventing itself through the exchange of matter, energy, and information between star systems. Tonight, we've traveled together through layers of possibility and wonder, exploring how a single object from another star might carry influences we can barely imagine. We've contemplated invisible seeds drifting through space, quantum echoes reverberating through the cosmic web, and the slow collapse of one state of being into another. We've decoded messages written in starlight and calculated the probability of wonders yet to come. And through it all, 3i Atlas has been our guide, a concrete example of the abstract principles that govern our universe. Think back to that moment when 3 Atlas was first detected, a faint point of light moving against the background stars. Astronomers around the world turned their instruments toward it, eager to learn what they could during its brief visit. In those weeks and months of observation, humanity came together in a shared endeavor of discovery, united by curiosity about this messenger from beyond. We may speak different languages and hold different beliefs, but we all looked up at the same cosmic visitor with the same sense of wonder. What have we learned from 3i Atlas? On one level, we've gathered scientific data about its composition, structure, and behavior. We've refined our models of how interstellar objects form and evolve. We've tested our theories against observations and found both confirmations and puzzles. But on a deeper level, 3i Atlas has taught us about our place in the cosmos, about the connections that bind star systems together, about the possibilities that await discovery. The fragmentation of 3i Atlas as it approached the sun was like a cosmic flower blooming in fast forward, revealing inner petals that had been hidden for billions of years. Each fragment told its own story, carried its own information about conditions in another star system. Some of these fragments might still be in our solar system, too small to detect but carrying their alien heritage as they orbit the sun or drift toward the outer darkness. They are seeds that have been planted, though we don't yet know what might grow from them. In the vast quietude of space, questions matter more than answers, because every answer opens doorways to new questions. 3i Atlas has given us a lifetime of questions to explore. How common are interstellar objects? What fraction carry exotic matter or unusual properties? How do they influence the evolution of planetary systems? Could they carry life or its precursors between stars? Do they play a role in the fine-tuning of physical constants or the emergence of complexity? Each question branches into others, creating a tree of inquiry that could occupy scientists for centuries. We rest in the peaceful knowledge that we're part of an ever-unfolding cosmic story, a narrative that began with the Big Bang and continues through every moment of existence. Our chapter in this story is brief, a few decades of consciousness in a universe billions of years old. But through science, we've learned to read earlier chapters and glimpse future ones. 3 Atlas is a paragraph in this cosmic book, a passage that connects our chapter to others written around distant stars. Consider how the story of 3I Atlas will be remembered in the future, centuries from now when humanity has spread to other worlds or evolved into something we can't imagine. What will they think of our first encounters with interstellar objects? Will 3I Atlas be remembered as a curiosity, a footnote in astronomical history? Or will it be seen as a turning point, the moment when humanity began to understand its true cosmic context? Perhaps future scientists will discover that 3 Atlas did indeed carry seeds of change, influences that shaped the development of our solar system in ways we couldn't detect with our primitive instruments. The possibility of transformation that 3 Atlas represents extends beyond physical changes to philosophical and spiritual ones. Every expansion of our cosmic awareness transforms us. When we learned Earth orbits the Sun, when we discovered the universe is expanding, when we detected gravitational waves, each discovery changed not just our knowledge but our sense of who we are and what's possible. The discovery of interstellar objects is another such transformation, showing us that we're not isolated but part of a galactic community. As you lie here, suspended between waking and sleeping, you're experiencing your own transformation. The thoughts and ideas we've explored tonight are creating new neural connections in your brain, new patterns that didn't exist before. In a small way, you've been changed by contemplating 3I Atlas and its implications. The seeds of new understanding have been planted in your consciousness, and who knows what insights might bloom from them in dreams or future contemplation. Dreams themselves might be a kind of collapse, a nightly transformation where the accumulated experiences and thoughts of the day reorganize themselves into new patterns. As you approach sleep, your brain is preparing for this transformation, loosening the connections that maintain waking consciousness, allowing new configurations to emerge. Perhaps dreams are how consciousness explores its possibility space, trying out different arrangements of memory and imagination. What dreams might 3I Atlas inspire? Perhaps you'll dream of riding along with it through interstellar space, experiencing the cold darkness between stars, the patient journey across cosmic distances. Perhaps you'll dream of its home system, imagining alien suns and planets we'll never see. Perhaps you'll dream of future encounters with interstellar objects, of missions to intercept and study them, of discoveries that transform our understanding of the universe. The universe itself might dream, if consciousness is more fundamental than we realize. Some theories suggest that consciousness might be a basic property of matter, present in some form at every level of organization. If this is true, then stars might have some form of awareness. Planets might experience something analogous to sensation, and the universe as a whole might possess a kind of cosmic consciousness. In this view, 3D Atlas might have been a thought in the cosmic mind, a memory being transferred from one region of awareness to another. But let's return from these speculative heights to the solid ground of what we know. 3I Atlas was real, observed by multiple telescopes, its trajectory calculated with precision, its spectrum analyzed with sophisticated instruments. It was a physical object, subject to the laws of physics, following a predictable path through space. Yet even in its physicality, it carried mystery and wonder. Every scientific observation raised poetic questions about origin, purpose, and possibility. The tension between knowledge and mystery, between what we understand and what we don't, is what drives science forward. If we knew everything, there would be no reason to look up at the stars. If we knew nothing, we wouldn't know how to look. we exist in the sweet spot between complete ignorance and complete knowledge, where discovery is possible and wonder is justified. The Atlas has shown us how much we still have to learn, how many mysteries remain in what might seem like empty space. As the boundaries between your waking thoughts and approaching dreams begin to blur, consider how boundaries throughout the universe might be more fluid than they appear. The boundary between our solar system and interstellar space isn't a wall but a gradual transition. The boundary between life and non-life might be similarly gradual, with viruses and prions occupying intermediate states. The boundary between one moment and the next, between cause and effect, between possible and actual, all of these might be less definite than our everyday experience suggests. 3i Atlas crossed many boundaries during its journey. It crossed the boundary of its home system, entering interstellar space. It crossed the heliopause, entering our solar system. It crossed the frost line, where volatile ices begin to sublimate. It crossed the point of no return where the sun's gravity could no longer capture it. Each boundary crossing was a transformation, a change in the forces and influences acting upon it. We too cross boundaries constantly, though we might not always recognize them. The seeds that 3i Atlas might have carried, physical, informational, or quantum, don't respect boundaries. If they exist, they've dispersed through our solar system, carried by solar wind and radiation, gravity, and chance. They might be in Earth's atmosphere in the solar corona, in the icy moons of Jupiter, or drifting toward the Oort cloud. Like seeds carried by wind on Earth, they go where physics takes them, potentially taking root in unexpected places. What might grow from these seeds? Not necessarily anything dramatic or visible. Perhaps just subtle influences on probability distributions, slight biases in quantum events, gentle nudges to the evolution of complex systems. The universe often works through accumulation of small effects rather than dramatic interventions. A single cosmic ray can cause a mutation that changes the course of evolution. A single gravitational perturbation can alter an orbit that leads to a collision millions of years later. If 3i Atlas planted seeds, their growth might be similarly subtle but ultimately significant. The metaphor of seeds and growth reminds us that the universe is not static but creative, constantly generating new forms and possibilities. Galaxies grow from tiny density fluctuations. Stars grow from collapsing gas clouds. Planets grow from swirling disks of dust. Life grows from chemical reactions. Consciousness grows from neural activity. At every scale, the universe exhibits this tendency toward growth and complexification, despite the second law of thermodynamics that predicts increasing entropy. Perhaps what we call seeds of collapse are really seeds of creativity, catalysts for the universe's ongoing self-organization. 3i Atlas might have been an agent of cosmic creativity, carrying templates or influences that promote the emergence of new patterns. These patterns might be physical, like crystal structures or chemical reactions. They might be informational, like algorithms or codes. They might be something we don't have words for yet, new categories of existence waiting to be discovered. As sleep approaches, that daily collapse of waking consciousness into the dream state, remember that collapse and creation are often the same process viewed from different perspectives. When a star collapses, it creates heavy elements. When certainty collapses, it creates opportunity for discovery. When isolation collapses, it creates connection. The seeds of collapse that 3i Atlas might have carried could be seeds of connection, linking our solar system to the wider galaxy in ways that will only become apparent over time. The story of 3i Atlas is far from over. Its influence on our solar system, whatever form that might take, will continue to unfold over geological and cosmic timescales. Future generations might discover effects we can't detect, connections we can't see, patterns we can't recognize. They might look back at our observations of 3i Atlas and see clues we missed, significance we didn't appreciate. Or they might discover that it was exactly what it appeared to be, a chunk of ice and rock from another star, remarkable only for its interstellar origin. Either possibility is wonderful. If 3i Atlas carried exotic influences that will transform our solar system, we've witnessed the beginning of a cosmic metamorphosis. If it was ordinary, we've learned that the ordinary processes of the universe include regular exchange of material between star systems, that we're part of a galactic ecosystem we're only beginning to understand. Wonder doesn't require the extraordinary, it only requires open eyes and an open mind. As you finally drift into sleep, carried by the gentle rhythm of your breathing like 3i Atlas carried by the solar wind, know that you're part of this cosmic story. The atoms in your body have travelled between stars. The thoughts in your mind connect you to the universe's long contemplation of itself. You are made of cosmic material, shaped by cosmic forces, participating in cosmic evolution. In sleeping, you join the rhythm of the cosmos, the cycle of activity and rest that pulses through everything from atoms to galaxies. 3i Atlas continues its journey through the darkness, moving away from our sun at tens of kilometers per second. In a few years, it will be beyond the orbit of Neptune. In a few decades, it will leave the Kuiper Belt behind. In a few centuries, it will be truly in interstellar space again, drifting through the void between stars. It might wander for millions of years before encountering another star system, or it might never have another close encounter, destined to drift through darkness until the universe itself ends. But its legacy remains with us, in the data we collected, in the questions it raised, in the wonder it inspired. Every scientific paper written about 3i Atlas, every conversation it sparked, every dream it appeared in, these are all echoes of its passage, ripples spreading through human consciousness and culture. We are different because 3i Atlas passed by, even if only in small ways. The seeds it planted might be seeds of knowledge, growing slowly in the garden of human understanding. What other cosmic visitors are approaching? As our detection capabilities improve, we'll discover more interstellar objects, each one a new mystery to explore. Some might be similar to 3i Atlas, others radically different. Some might clearly be natural, others might make us wonder. Each one will add to our understanding of the galaxy and our place within it. The story that began with Oumuamua and continued with 2i Borisov and 3i Atlas is just the first chapter of a book we'll be reading for generations. In your dreams tonight, you might find yourself drifting through space like an interstellar object, carrying your own seeds of possibility from one star system to another. You might experience the patient journey across cosmic distances, the brief excitement of a solar encounter, the return to the peaceful darkness. Or you might dream of things that have nothing to do with space, your unconscious mind processing the day's experiences in its own mysterious way. Either way, you're participating in transformation, the nightly collapse and reconstruction of consciousness that keeps us healthy and creative. The universe continues its patient evolution, indifferent to our individual lives, but somehow including us in its grand unfolding. Stars are being born and dying at this very moment. Galaxies are colliding and merging. Black holes are swallowing matter and emitting jets. Dark energy is accelerating cosmic expansion. And somewhere in this vast cosmic dance, 3i Atlas continues its journey, a small but significant participant in the universe's exploration of its own possibilities. Perhaps the most profound seed that 3i Atlas has planted is the seed of cosmic awareness in human consciousness. We now know, not just intellectually but experientially, that our solar system is visited by objects from other stars. We've seen one, studied it, watched it arrive and depart. This knowledge changes us, expands our sense of home to include not just Earth, not just the solar system, but the galaxy itself. We are galactic citizens, whether we realize it or not. As this documentary draws to a close, as you surrender to sleep's gentle embrace, remember that endings are also beginnings. The end of waking consciousness is the beginning of dreams. The end of 3i Atlas's visit was the beginning of its influence on our understanding. The end of one cosmic cycle is the beginning of another. In the universe's patient transformation of matter and energy, in its exploration of possibility through probability, there are no true endings, only transitions. Could 3i Atlas carry the seeds of collapse? Perhaps. But if so, they are seeds of creative collapse, of transformation rather than destruction, of becoming rather than ending. The universe has been collapsing and reforming, dying and being reborn for billions of years. We are products of countless such transformations, and we will contribute to countless more. 3 Atlas was a messenger in this eternal process, a carrier of possibility in a universe that never stops exploring what might be. Sleep now and dream of distant shores, of cosmic visitors and stellar journeys, of seeds planted and gardens growing, of a universe vast beyond imagination yet intimate as your own breath. You're safe within the cosmic architecture, held by forces that have maintained stability for billions of years, yet you're also part of the universe's creative edge, where new possibilities are always emerging. 3i Atlas has passed by, but its story continues in the data we analyze, the theories we develop, the dreams we dream. In the morning you'll wake transformed, your brain having reorganized its memories and connections during sleep. You'll carry with you some trace of tonight's contemplation, some seed planted by thinking about cosmic visitors and quantum mysteries. Perhaps it will influence your perspective on the day ahead, helping you see ordinary events as part of the cosmic story. Perhaps it will simply leave you with a sense of wonder, a recognition that we live in a universe far stranger and more beautiful than we usually realize. The cosmos continues its patient evolution, with or without our awareness, but choosing to pay attention, to wonder, to question, makes us active participants rather than passive observers. 3i Atlas invited us to participate, to look up from our earthly concerns and consider our cosmic context. It reminded us that we're not alone in the universe, that other star systems exist and occasionally send us messages in the form of wandering ice and rock. What messages might we send in return? Not deliberately perhaps, but inevitably. Our sun has ejected objects that are now wandering through interstellar space. Some carry evidence of our solar system's composition and history. A few carry artifacts of human civilization, the Pioneer and Voyager spacecraft, heading into the darkness with their golden records and plaques. We too are sending seeds into the cosmos, though we don't know what might grow from them. As consciousness finally dissolves into sleep, as your awareness of these words fades into dreams, you become like 3i Atlas itself, a wanderer through spaces of possibility, carrying seeds of thought and memory, creating echoes in the quantum field of consciousness. Your journey tonight has taken you billions of miles and billions of years, from the formation of an interstellar object around a distant star to its passage through our solar system, to its continued journey into the unknown. Rest now in the peace of cosmic perspective, where our small concerns are held within vast cycles of creation and transformation. 3i Atlas has shown us that the universe is more connected than we imagined, that star systems communicate through the exchange of matter and perhaps more subtle influences. We are not isolated islands, but part of a galactic archipelago, connected by currents of matter, energy, and information we're only beginning to map. The seeds of collapse, if they exist, are nothing to fear. They are part of the universe's creative process, its method of exploring new possibilities and generating complexity. Whether 3i Atlas carried such seeds, or was simply a wandering piece of cosmic ice, its passage has enriched our understanding and expanded our perspective. It has shown us that the cosmos is full of surprises, that even empty space contains wonders, that patience and observation can reveal profound truths. In the silence between stars, in the darkness between galaxies, the universe continues its ancient dance of matter and energy, information and entropy, creation and transformation. 3i Atlas was one note in this cosmic symphony, brief but meaningful, simple but profound. We were privileged to hear it, to record it, to add our own harmonies of observation and interpretation. The music continues, with or without our listening, but choosing to listen makes us part of the performance. Dream well, cosmic traveller. You've journeyed far tonight, from the familiar confines of Earth to the vast expanses of interstellar space, from the certainties of everyday experience to the mysteries of quantum possibility. You've contemplated seeds too small to see and structures too large to comprehend. You've calculated probabilities and decoded starlight. You've wondered about collapse and transformation, about echoes and connections, about the nature of reality itself. Tomorrow, the sun will rise, and the ordinary world will reassert itself. But perhaps you'll remember something of tonight's journey, some sense of the cosmic context that surrounds our everyday lives. Perhaps you'll look at the sky with new eyes, knowing that interstellar visitors pass through regularly, that we're connected to distant stars, that the universe is far stranger and more wonderful than it appears. Perhaps you'll carry with you a seed planted by Three-Eye Atlas, a seed of wonder that will grow throughout your life. The universe is patient. It has billions of years to unfold its possibilities, to explore its potential, to transform itself through cycles of collapse and creation. We have only brief decades to participate in this cosmic evolution, but what a privilege those decades are. To be conscious in a universe becoming conscious of itself, to be able to wonder about wanderers like Three-Eye Atlas, to dream of distant shores and cosmic connections. This is the gift of being human at this moment in cosmic history. Could Three-Eye Atlas carry the seeds of collapse? The question remains open, awaiting future discoveries and deeper understanding. But whether or not it carried exotic seeds, it certainly carried seeds of knowledge, seeds of wonder, seeds of cosmic awareness. These seeds are growing now in the minds of all who have learned about this interstellar visitor, spreading through human culture like ripples on a cosmic pond. As sleep finally claims you, as the last conscious thoughts dissolve into dreams, you become part of the universe's nightly transformation, the collapse of waking into sleeping, the transition from one state of consciousness to another. In this small personal collapse, you mirror the cosmic processes we've been contemplating. You are the universe experiencing itself, transforming itself, exploring its own possibilities through the miracle of consciousness. Three Atlas continues its journey through the darkness, carrying its secrets toward unknown destinations. We continue our journey too, orbiting our sun, spinning through space, participants in the cosmic dance whether we're aware of it or not. The seeds that might have been planted during this encounter, physical, quantum, or conceptual, will germinate in their own time, revealing their nature through patient observation and contemplation. The story ends where it began, with wonder at the vast mysteries surrounding us, with gratitude for the glimpse of cosmic truth that Three-Eye Atlas provided, with anticipation for future discoveries that will expand our understanding even further. In the grand narrative of the universe, we've shared a page, a paragraph, a sentence with an interstellar visitor. That sentence now becomes part of our story, woven into the fabric of human knowledge and wonder. Sleep peacefully in the cosmic web, held by forces that connect all things, surrounded by mysteries that make existence an endless adventure. Through Atlas was a reminder that adventure comes to us even when we stay still, that the universe delivers wonders to our doorstep, that patience and attention are rewarded with profound discoveries. The seeds of collapse, should they exist, are also seeds of possibility, seeds of transformation, seeds of a future we can barely imagine. The cosmos whispers its secrets to those who listen carefully, reveals its wonders to those who watch patiently, shares its mysteries with those who dare to wonder. Tonight, you've been such a listener, watcher, wanderer. You've travelled with Three-Eye Atlas across unimaginable distances, contemplated possibilities beyond ordinary experience, touched the edge of cosmic mystery. Now rest, and let the universe continue its patient work while you dream of distant shores, cosmic visitors, and the endless dance of transformation that connects all things in the vast, beautiful, mysterious cosmos we call home.